Hello grade 12, welcome to my channel. Let us have a look at this question paper from 2016. This was a request by one of you guys, and I do hope that the person who requested this is watching this video, and hopefully it met your requirements for some understanding and perhaps some strategies in dealing with this question. So this is a paper 2 which is very important to master. The three major topics, in essence it's just two major topics. It's trigonometry and Euclidean geometry, because analytical geometry is more of the in-between. If there is no trigonometric knowledge as well as Euclidean geometry knowledge, and essentially more work from paper 1, functions, straight line equations, and algebra, then analytical geometry becomes a nightmare. Okay, so of course instructions, guys, are very important, but as always we need to locate these kinds of instructions, where in all calculations we need to show everything. If we used some diagrams, we need to show them. If there's a graph, we need to show it. And the etc. part can be absolutely anything that is acceptable in maths when solving problems, be it a reason or something. All right, so comes the issue of rounding off, because this is also very important to adhere to instructions. So we round off answers to 2 decimal places. Remember, this is specific, saying 2, no more, no less. Okay, very important to ensure that for each question paper that you attempt as a student, or at least for each question paper that a student sits for, this is clear, because this instruction is not for all question papers, but it's specific to a particular question paper. So we need to be very careful when dealing with issues here. Otherwise, diagrams are not necessarily drawn to scale, meaning do not read too much into the diagram per se, but ensure that it transmits the correct information. Okay. Otherwise, we do have a formula sheet at the end here, where we can remind ourselves of any formulae we may have forgotten. So let's get to question 1 without a waste of time. Now question 1 is the easy thing, statistics. On a certain day, a tour operator sent 11 tour buses to 11 different destinations. All right, now the table below shows the number of passengers on each bus. So this means on the first bus, if this be the first bus, or on this particular bus, there were 8, on another there were 8, on another there were 10, on another there were 12, 16, 19, 20, and so forth. Okay, great. So this is just the buses, all right, and the passengers inside each. We need to calculate the mean number of passengers traveling in a tour bus. Okay, so here the mean is very simple. We are just going to essentially add all those numbers nicely. But what is nice here, it's very easy to just put the data onto the calculator. So we just go to mode, and on mode we are going to choose statistics, which is option 3. Now remember, there's one variable here, it's just number of passengers, so we're going to choose one variable, statistics or analysis, whatever this is called. So we're going to choose one var, okay, or VAR. So that's option 1. And we can see that soon as we hit that, we see a table with just X. So we just input those values, 8, 8, 10, 12, 16, 19, 20, 21, 24, 25, 26, and we can see that we have 11 inputs. So all we do, we press the AC button. It simply stores our data. Now we just go on and press the shift button, and then we put the statistics or button number 1, which is written stat at the top. And what do we do now? We are going to choose the variance, which is VAR, which is now option 4. And in here, we can choose the mean, which is the X bar. So very easy. 1.1. X bar here, we're going to just select option 2. And it gives us the answer. So this is 17,18. Right. Remember, instruction says 2 decimal places, no more, no less. Okay. Right. So that's good. So easy 2 marks here. This is calculator work. All right. So 1.2. What are we supposed to do? We need to write down the 5-number summary of the data. Okay. Very easy. Let's see. We need to divide this data right in the middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we need to at least look for 5 below and 5 above. So this is 1, 2, 3, 4, 5. Okay. So we leave this box alone. And then we'll see 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So that's the middle. So now we need the middle of the middle here. So it's going to be 2 on either side, right? So this becomes the middle for the data below, right? And this has to be the middle of the data above the middle of the middle. So for this data right here, we will see that the middle is those values. So what is the middle? First of all, this becomes the median, which is Q2, right? So this becomes Q1, right? This becomes Q3. So that's what we need. And then, of course, we look and check. We need the minimum value. So we can see this is the smallest value ever. So this becomes the minimum. And the maximum value is the biggest value. So we have our 5-number summary. Nice and easy. So how we write it, we will start from the minimum. This is going to be equal to 8. And we go on to Q1. Q1 is 10. And then we go to Q2. That's 19. And then we go to Q3. This is 24. And then we go to a maximum. This is going to be 26. All right, so we have our 5-number summary right there. So this simply says we're getting 3 marks. I don't know how these 3 marks come about, but whatever. The number doesn't match, these things that we're supposed to deal with, but that's what it is. So very easy, not a complex question. 1.3. We need to draw a box and whisker diagram for the data, and we are to use the number line provided. Now remember, you cannot draw your own as a student. We need to use one that is provided, because there is a catch even right there. So there is a catch, because one that we can draw for ourselves will always make it easy. So let me just check if I have that stuff over there. I actually didn't look this question paper up, so now I don't have. So folks, unfortunately, when downloading this question paper, please take care to download the answer sheet if you can find it, so that as you attempt to respond to the questions, at least we adhere to instructions. This is an instruction, it's not an option. It's an instruction. So this means we only adhere to this particular instruction. Unfortunately, I do not have, so I'm going to make my own. All right, maybe let's just start with the stuff that matters. We need to draw a number line first. On this number line, we know that we're going to have our minimum. Okay, maybe not necessarily minimum. We can make this one 0. I mean, we're going in 2s here. So, okay, 3s, whatever. So, let's just say 1 through 20 or 1 through 30. It's going to be very easy. So, this is 1, okay, 0. 1. Oh, gosh, yeah. This is going to be terrible. Alright guys, so there is my little grade right there, or the scale or number line that I tried. Okay, so obviously this is forbidden. We need to use the one provided, so that, remember, there is a catch right there. Knowing how to deal with the scale is very important. Anyway, let's go for it. So we know that Q1 is at 10. So we will start here. And then we go all the way to 24, 21, 22, 23, 24, and we go and we come back. So this is more like it. And at 19, we had our Q2 right there. Okay, it's starting to make me a little bit unhappy. Okay, it's something like this, folks. Remember, it's not exactly as nice as I want. Yeah, and minimum here is 5, 6, 7, 8. So there it is. Just go in nicely. Why isn't it making a straight line? Trying to irritate me. And maximum is 26 right here. Okay, so there is our box and whisker diagram. It's as required. Okay, so far so good. This is good, this is good, this is nice. Anyway, we move on. How many marks were scored here? 2 marks. Okay, however these 2 marks are given. Let's move on. We need to refer to the box and whisker diagram and comment on the skewness of the data set. All right, so we can clearly see that there's more data below Q2 than there is above Q2. So this is already suggesting that this is skewed to the left. Okay, where there's more data, then that's where the skewing is. And where there's less data, that's where the skewing is not. Of course, if we're to draw a distribution curve, it would be something like this. right? Hey, am I right? I think so. It should be something like this. Yes. So there's more data this side. And in fact, we can even think about the mean. What was the mean? The mean is 17, this situation right there. And can you see the mean is to the left of the median, which was Q2. So can you see the mean is to the left of the median? So this is exactly what this means. All right, okay, all right. So we understand what we're dealing with. We just move on, okay? I don't know if this graph is right, but yeah, it sounds right to me. Anyway, let's not waste time, guys. So 1.4, we said the data is skewed to the left. Okay, nice and easy. Just an easy 1 mark over there. We move on. So 1.5. We need to calculate the standard deviation of this data set. Again, we just go to the calculator, nice and easy. So we go shift, stat, and then we go for the variance. And the standard deviation is option 3. So since our data was stored, so the standard deviation is this smaller or lowercase sigma. So this is 6, again, we're going to do 2 decimal places. This is 4, 6. All right, nice and easy. So remember, this is passengers. Of course, one may want to round off to the nearest integer because we never have 6 people and some stupid numbers there, okay? But again, it's not a big deal. At this stage, we just keep things as simple as they are, and we try to adhere to the instructions as best as possible. Again, we get our 2 marks here, nothing difficult. So 1.6. 1.6 asks, or at least there's a story. A tour is regarded as popular if the number of passengers on a tour bus is 1 standard deviation above the mean. Okay, 1 standard deviation above the mean. So that means we're going to say the mean plus the standard deviation. All right, so that's what we need to do. And of course, we are going to do that. What was the mean? We got 17,18 plus the mean, the standard deviation is 6,46. So what is that? So let's see, 17. Okay, now we are done here. We can just go back to the normal mode, which is the computing mode. So we have 17,18 plus 6,46. So this is 23,64. So this is going to be a value 1 standard deviation above the mean. Okay, great. So this can be a side calculation. You don't need to show it, honestly. All we need to do is just to respond to that question. How many destinations were popular on this day? And we can clearly see anything above 23.64 is definitely going to be these particular ones. 24, 25, 26. Okay, so it was 3 destinations. So let's write it nicely. 3 destinations were popular. Right. So this is again an easy question, not one to really flinch on. So these were essentially very easy 12 marks, to be honest. All right. Do hope you guys have done well on this one. Otherwise, it's not a difficult question. All right. Good. Okay. So we move on. Of course, guys, there's many ways to state certain things in maths. You may want to say skewed to the left or negatively skewed. So there are some terms that can be used. Negatively skewed. That can also be used as a substitute to saying skewed to the left. Sometimes a reason may be asked. One can state that the mean lies to the left of the median. So sometimes the reason for this is saying the mean lies to the left of the median. Okay. That's the reason for that comment. Okay. Because these questions are peddled all the time. So at times there may be a question as to why. Okay, or somebody may use the box and whisk and say there's more data values or data points to the left of the median than there are to the right. Of course, that may need a bit of a serious check than just, carelessness. Some people may just take the median and subtract the minimum to check this issue. So the median, we saw that it was 19. Then we subtract 8. We will see that it's 11. But when we take the maximum and subtract the median, so let's say 26 minus 19, can you see it's 7? So that's less data points above the median than there are below the median. So there's many ways to look at this. Other people may just look at the areas in between Q1 and Q2 and Q2 and Q3, and that can also give some indication of skewness. Okay, very important to watch out for those kinds of things. And then of course, folks, maths is always maths. Nothing else is really extraordinary here. Of course, I'm taking more time to answer a very simple question just to highlight a few things that a student needs to pay attention to as they proceed with their quest for good performances in maths. Now let's just do question 2 on a new page. Now, question 2 reads, on the first school day of each month, information is recorded about the temperature at midday in degrees Celsius. Okay, temperature at midday. How? In degrees Celsius. So guys, these are very important pieces of information each month. On the first school day of each month, can you see there's so many things to think about? Of course, I know a lot of, okay, let's not comment on that because we're going to sound a little less mysterious and perhaps, infuriate some fragile souls out there, and there's plenty of them. Now, we are saying this situation right here, described in this piece of information, is that on the first school day of each month, information is recorded about the temperature at midday. And the number of 500 milliliter bottles of water that were sold at a tuck shop, okay, of a certain school during lunch break. So there's so much to take in. Of course, examiners do this deliberately to give a very wordy type of information to get the student to lose the track of what is important. But if one makes sure that they get every piece that is given, it becomes easier to overlook certain things while taking care not to be too ignorant enough to lose, what is important. The essence of what is given is to come in. Here, what seems to be more important is the number of bottles of water sold in a tuck shop as an indication of some sort of temperature on a particular day, midday, at the beginning of each month in a particular school. Now the data is shown in the table below and represented on the scatter plot. The least squares regression line for this data is drawn on the scatter plot. Easy. Now we've got this piece right here, temperature at midday, the number of bottles. Now remember, if we think about it, which one influences the other? Can the number of bottles influence the temperature, for example? Not necessarily. But we can work back once we establish a relationship. But the temperature at midday becomes the dependent variable, right? Because if it is hot, obviously, there is going to be more bottles being sold. But if it is cold, definitely no bottles of water, but more, cup coffees or cappuccinos and stuff. So this is the dependent variable. So always make sure you understand what comes before the other. Although we can work back the other stuff once we establish some sort of a relationship between the two variables. But the other one, if we were to look at it in isolation, we would not be able to work it back to this one, essentially, in a sensible way. Of course, guys, there are some exceptions to certain things, but be on the lookout of such things, because at times there is no indication as to what must be what. But the good thing is, if the scatter plot is provided, we just check what is on the y-axis, the number of bottles, and always what is on the y-axis is the dependent variable, right? Why is this thing not so straight? And of course, the independent is what is plotted on the x-axis. So this is very good to know and understand how things are structured so that we can answer properly without issues. Of course, we can see there is our least squares regression line, and every data point, okay, these data points are closely packed along or around this line. So this means there's good correlation, and this is a positive correlation. Okay, it's a strong positive correlation because this gradient is increasing. Of course, there's this dude right here. This dude is far from this line compared to the others, right? Right. And how do we know this? Let's say, okay, these ones are too close, but this one looks a bit far. Let's just check. Let's just take that distance and measure it. Move. Can you see this one is way, way, way far from this line? But can you see others are within this particular distance? So it's always nicer to know how to do things, okay? I always had ways of doing things. So what I would take to do this business is just a sheet of paper. And on a sheet of paper, I just place it so that this is perpendicular to the line. And then I just mark off like this. And then I move this paper all around and see who is further from this line compared to the others. So essentially, there's many tricks I can tell you about, but yeah, that's it. So we can see this guy is further from this line compared to the others. So this is most likely what we call an outlier. Okay. All right, okay. Now, there can be a question as to why is there such a situation. Think about it as well as a student. Of course, during your practice sessions, in the exam, maybe there's not much time to waste on thinking about what is not being asked. Because in the exam, it also helps to skim and scan these questions so that your thought process is not flying all over the show, because it's all about answering these questions as best as possible. But I can tell you there are certain sections that do not help if you scan and skim the questions, because you just get yourself into trouble. Things like Euclidean geometry, you will not be forgiven if you do that. Analytical geometry does not necessarily forgive on the higher order questions if this is the approach. But certain questions like statistics, there are a lot of things you want to consider, but they're not really that important for the given question. So sometimes be as dynamic as these questions get. Anyway, let's leave the stories. It's enough to waste our time. Anyway, so what could be the reason that there's an outlier like this? I mean, it means on this particular day we sold more bottles than we would expect to. So what could be the reason? Maybe the damn things are on a special, right? So they are cheap. So these guys just bought them because they can afford them now. All right, so it could be that reason. Because when everything is on special, it doesn't matter if it's relevant to have a water bottle on that day. They'll just drink it anyway because it's cheap. Everybody can afford it. So that could be the reason, you know. So the shop is trying to clear the stock because perhaps they've been there too long. They're almost nearing their expiry dates and stuff. So there can be a lot of reasons for this to be the case. But these are things to think about, because for practical purposes, we need to understand, what do we understand by these things when we are conducting some serious research and are looking to publish those results? What is the significance of these things? Or at least the reader needs to think about what could be indicated by what is depicted on the scatter plot. Anyway, guys, let's not hold you down too long. Let's get to the answers. 2.1, we need to identify an outlier in the data. All right, so where's the outlier? That's the outlier. So we need to read it out. So the outlier, we go on and trace it back. Yeah, doch, this thing is not a straight line, so now I need to try and be as good as I can be. All right, so there it is. So we need to understand the scale. Of course, guys, I'm not going to emphasize all of this all the time. You need to know how to do it. So from 5, we got to 10. So this is 6, 7, 8, 9, 10. So every little line represents one tick starting from 5. So this means this is 51, 52, 53. So that's 53, and of course the temperature was 30 degrees. So this is a point. So an outlier is a point. So yeah, so now we need to present this as a point. So the outlier was 30 degrees Celsius, and essentially 53 bottles of water. All right, that's the best way I would present that information. But again, there's plenty of ways of doing this. So don't cry if you find my approach a little less accurate. You know, some students may even want to elaborate and say 53 bottles of water. Remember, this is science. So I wonder if anybody knows what this is mathematically. Yeah, you're just trying to impress the lecturer, especially if the teacher of maths is still the same teacher for physics, so you're wanting to impress. I mean, it doesn't really matter. So even if the units are not included, perhaps you can write 30 is to 53. That's still okay, right? Not a big deal. Next question. So we're scoring 1 mark for this. The next question says, determine the equation of the least squares regression line. Again, this one is best done on the calculator. So we go mode, then we choose stats, which is option 3. This time we're going to choose option 2, which is a plus bx. Okay. Now we get our bivariate data table. Now we're going to input all the x values. So this is 18, 21, 19, 26, 32, 35, 36, 40, 38, 30, 25. Of course, guys, during this period, it's nice to count how many these are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11 of these, and I have 11 inputs. And I use my arrow to move over to the Y column. And then I take it right back to the beginning. So 18 went with 12. Make sure these pair nicely. Then the next one is 15, 13, 31, 46, 51, 57, 70, 63, 53, 23. So everything looks like it's matching. So we just press the AC button. This stores our data, and then we go shift, button number 1, statistics, and then we choose option 5, which is regression. And here we need the A value, the B value. So we go A, which is option 1. It gives us minus 38, 5, 1 to 2 decimal places. Then we just repeat the process, shift, stat, regression. We choose number 2 for B, and it gives us a 2,68. Okay, to 2 decimal places. Therefore, Y accent is going to be A, which is minus 38,51 plus 2,68 x. Okay, so that's how we write the least squares regression line. Very easy. We normally get a mark for each of these situations. It always helps to underline the final answer, all right, to show that there's no more continuation of that solution. Anyway, however you were taught to do this, perhaps stick with that. Now, we need to estimate the number of 500 milliliter bottles of water that will be sold if the temperature is 28 degrees Celsius at midday. That's easy. We're just going to use our least squares regression line to do the prediction. Instead of x, we're going to plug the 28 right there. Therefore, we will see what comes up. So minus 38,51 plus 2,68 into 28. It gives us 36,53. Now the question is, what on earth is that? Remember, on our data, We don't have commas because how can we have 36,53 bottles? So we need to round up. Of course, this is 5 is significant. So this is roughly 37 bottles. So we can say, therefore, approximately. Yes, it's an approximation. Approximately 37 bottles of water were sold on that day. Okay, not a big deal. Of course, this can be written as a symbol. Remember, approximation is this wave and some equal sign underneath. So that's what we use. So you can just write this. Okay, not a big deal. So hopefully you guys got that one nice and easy. So how do we score marks here? 2 marks. Fine, the substitution and the final answer. Okay, because remember, we cannot leave the answer here. We don't have bottles like this. So we would say approximately this. Perhaps this one fell on the ground and it got spilled. And perhaps we can say all that remained was maybe half of the bottle, so to speak. And we perhaps, the one who bought one bottle around that time, we gave this one as a bonus or something like that. Or perhaps, yeah, something like that. I mean, I don't know how to explain this, but yeah, that's it. Anyway, folks, this is not a big question after all. Oops. So we're doing 2.4. 2.4 is asking for us to refer to the scatter plot. Okay. Would you say that the relation between the temperature at midday and the number of 500 milliliter bottles of water sold is weak or strong? Of course it is strong. I will say it's strong. The reason is most data points are closely related to the least squares regression line. So we can say most of the data is closely related to the least squares regression line. Okay, they are very close. So we can say it's closely related or closely packed. Yeah, whatever, guys. Remember, when we answer, we need to answer in relation to the scatter plot, not the correlation coefficient that one can calculate. In fact, let's just check that one out and see what it shows us. So let's go to regression and choose option 3 and find R. Can you see this is 0.98? So R here is 0.98 to 2 decimal places. Can you see that's a very strong correlation between the two variables? So, but now we need to use the scatter plot to comment. So we can say most of the data points are closely related to the least squares regression line, except this dude. In fact, I don't know why I'm saying most, of course, yeah, because look at these ones. Look at those ones. They're very close, except those two. But again, these ones are not too far off either. I'm sure our comment is not too bad. But again, questions like these are essentially open-ended. So to really choose the strength, we get a mark. And for the motivation, of course, it has to be a fitting motivation rather than a dream. Okay, we cannot be dreaming here. Give a reason why the observed trend of this data cannot continue indefinitely. Holy cross. How can we say that? Of course, everything that we have here must fall within the domain of the given data, beyond which we cannot predict. Now, the reason for this is that we only interpolate. We don't want to extrapolate. So there's plenty of ways one can put an argument here. Is that the results here need to be an interpolation, which means we're going to predict issues within the given domain of our data, outside which we would be doing an extrapolation. That's something we cannot really truly believe or trust, because that is inherently inaccurate. Okay, so we can say, well, the results, I mean, there's many ways one can put this. There's no one particular way why this cannot continue indefinitely. We can say the results should be based, what can you say? What results are we talking about? The predictions. The predictions should be based within the domain given for some accuracy. All right, which we can call this an interpolation, outside which their predictions are inherently inaccurate. Inaccurate. I don't know how to write English, guys. Which would be an extrapolation. Guys, sometimes when you're not so sure how to really put it nicely, you throw in every punch as you can. Extrapolation. Guess what? That's the best argument I can put forward. So we'll say essentially the predictions should be based within the domain given for some accuracy, right? Because that would be an interpolation, outside which the predictions are inherently inaccurate, which would be an extrapolation. Of course, this is just 1 mark. Here I gave an argument of perhaps 2 marks. But again, this is when you're not so sure if what you're saying is, strong or not. But I would give a mark for a student who does this. Whether the memo says whatever it says, at the end of the day, yep, you are not prepared. Remember this, sometimes, yes, reading a particular textbook may suggest a best possible answer for this situation. This may be even explained. So these are the questions that say to you as a student, please read more on this. Okay? Because in the future, this question can come up again, but in a very strict manner. Find that the examiner has decided that this needs to be understood well. So there's many sources, textbooks, study guides, your so-called exam guidelines that you love so much. Please check them out for some better suggestions, of course. They're not stating the only things you should say, but they're saying most of the basic stuff that is expected, at least, if nothing else better is provided. So yeah, we cannot limit ourselves to the level of recommendations rather than some rules, okay? So, yeah, guys, let's not go into that field of politics. Almost, I am, to some extent, I guess, politically inclined in the academic arena because I hate politics for a living. Okay, maybe that's a strong word. I actually do not care for politics. I also don't take lots of politicians seriously because most of them are just populists who have nothing to offer but a lot of rant and rubbish to spew, causing divisions, all in an attempt to please the unfortunate multitudes who are foolish, to follow them and give them a chance at governance so that they can do as they please. At the end of the day, they don't really serve the population at all. You can clearly see from their behavior there's no diplomacy. The etiquette of their speeches that they make are ridiculous. So for me, any hooligan should not be looked at for things like presidency of a nation or an institution or any leadership position for that matter. Hooligans belong on the sidelines. They need to watch things happen. They can talk, they can make noise. We'll just take them as noisemakers and nothing more. But hey, we live in a world where every student believes that they know what is needed to make this country move forward, which is absolutely ridiculous. Because how can just simpletons know what is necessary anyway? They would never know. Even if they were to be given a chance to make a decision, they would most likely make the wrong decision. Because look, if you base decisions on emotion, you're more likely to lose every time you have taken a decision. In fact, you're more likely to regret. Sometimes you start to see yourself as being cursed because it seems you're making all the wrong moves. Why? Because your decisions are based on emotion, not on knowledge, facts, and some form of understanding. That's spiced up with some educated guess, because just pure guessing is not right. But an educated guess is best, because remember, you never know for sure. But you can be very close to the truth. Even when you realize, okay, I missed it by a moment, you can push yourself back right in without so much effort. But if you miss it completely, it's another situation to turn right back and be on track again. All right, anyway, guys, I don't know why I got there, but I just did. So if you want to cry, well, do it. Go into some corner somewhere, cry about it, hate me for it, come back and learn maths, right? Ke le kenya phafa jwale, ke le kenya phafa, ke le fa dintho tse thata jwale tsa batho ba baholo e seng bana. A ke re le batho ba baholo jwale ka baka la hore le 18 years and over, right? Yeah. Le haeba le haufi he ho 18 yona eo, empa le baholo jwala bana bona ba setse fule kwana ka bo grade 9 something. Ha o le high school, ha ke nahana hore ngwana, ke nahana hore motho a moholo nyana wa bona. Yeah, bana wa kgona ho bona. All right, folks, that was it on statistics. As you can see, guys, there's nothing here. Very easy questions. So let's look at question 3 now. This is where the big situations start to matter, because analytical geometry marries algebra, functions, sometimes calculus, with Euclidean geometry and trigonometry, right? So this is like the complete package of maths. I don't find in our metric curriculum any section of maths that is as complete as analytical geometry. because it puts everything together, right? Although it's not the difficult section by any long shot. It's actually the easiest geometry you can think about of the geometries. Yes, there are some questions. Higher order questions will anchor on some Euclidean geometry concepts that you may not see right away. You will have to remember them and see their utility to apply them. And some calculus knowledge may come in, especially when you talk about maxima and minima. Sometimes some knowledge on functions when it's all about reflections of points on the Cartesian plane. That constitutes the higher order questions. Otherwise, some direct, easy to see questions. They are purely just, grade 10, grade 11 work. Yeah, so there's nothing much here. Anyway, let's read with understanding. In the diagram below, not drawn to scale. So this highlight is very important. To not try to read too much onto what we see, but we try to. This looks like the question paper from KZN trial, huh? Didn't I do something like this? I did it. This diagram looks familiar. Anyway, let's look on. Point A with coordinates -8 and 6. So this is a point in the second quadrant. So we see it well represented. B with coordinates 8 and 10, again a point in the first quadrant, nicely represented. C, now if C is not given, it means it's a potential question. Just remember that. So this means C, watch out. We need to figure out how would we find those coordinates because it's a potential question. And D with coordinates 2 and 0, so it's indicated again, a point on the x-axis right on the negative x-axis, are the vertices of a trapezium. Now, do we know what a trapezium is? Now, a trapezium is a quadrilateral that has a pair of parallel sides, just one pair, a single pair of parallel sides. And the good thing is these are already indicated right here. So those ones are already indicated. So we don't need to worry about which sides are parallel. But if they were not given, we would have to calculate the gradients and see if they are the same. All right? Now, if we don't find this, then we would be in trouble. Okay. So, again, it would be a little challenging to do this. But the nice thing is we would probably say, okay, we would check that line because we've got coordinates, both coordinates on it, and perhaps this line because we've got F and D. At least we've got coordinates, even if we don't have those for C. We could check that. But then we would be in trouble if C is necessary because if this was not indicated, these are the two parallel ones. We would not know if this line is parallel to that. So it would force us to find a way indeed of looking for the coordinates of C. Obviously, there would be more information provided for us to thrive there. Having BC parallel to AD, okay, that sets us free because we were going to start having problems. Now, T is the midpoint of DB. Okay, great. Now, midpoint means x coordinate is the average of the x's here. So 8 minus 2, that's 6, divided by 2, that's 3. And then 10 plus 0, that's 10, divided by 2, that's 5. So that makes a bit of sense. That makes a bit of sense. So we just work with the information that is given. So this piece right here gives us those coordinates. For now, we're just putting things where they belong. We will still have to justify these when answering the questions. All right, not a problem. Now, what are we going to do next? Well, we have a lot that we can do. But let's read on. From B, the straight line drawn parallel to the y-axis. Now, what is a straight line drawn parallel to the y-axis? Well, we can indicate this situation also, obviously. So it means this line is perpendicular to the x-axis, and luckily this has been shown. Right. And now what does this mean? It means the x-coordinated m is the same as the x-coordinated f as well as the x-coordinated b, because that becomes a vertical line. Of course, on the x-axis that is 0. So these are the implications we need to take care of. Now that we have read everything, so we know that, okay, cuts DC in F, right, and we are given the coordinates and the x-axis at M. So we know that on the x-axis y is 0, so we just were given the coordinates of M indirectly. Now let's think, what can we do with this? Easy. We can find the equation of this line, the gradient of this line, its angle of inclination. We can, from the equation, read the y-intercept right over there. Great. Again, this one, we can find the gradient of this line. From the gradient, we can work out the angle of inclination. We can also work out the equation of this line, where we can easily read off its y-intercept. Okay, that's great. Same we can do for dB. We can work out the equation of this line mainly and its gradient, and we can read from the equation the y-intercept. The angle of inclination, not really quite an important issue for now, so we can leave that alone. Same for AD. We can work out the equation of this line. We already have the x-intercept. We can work out the gradient. We can also work out the angle of inclination of that line. Now, how would we find this point C? Well, this point C is a very nice point. It's a point of intersection of BC and AD. So what we can do, since we would have a way of finding the equation of that line DC or DF, we could have that equation, and remember the gradient of AD is the same as the gradient of BC. Using this point, we can work out the equation of this line. Now here we solve simultaneously. This is the point of intersection, and from simultaneous equations, we can have the x and the y coordinate. Unless we are given extra information, this seems to be the best way to approach this, because this is not a parallelogram where we could say, well, this is the midpoint of the diagonals. No, that's not the case for a trapezium. So don't get caught pants down, right? Right. Now let's start answering. Of course, once we have every little plan, we can see that we literally can do everything in this. Usually the grade 11 question, this is possible. With us, we had analytical geometry that was naughty. Questions from grade 11 were hardly asked in that manner. Maybe some parts of certain questions would perhaps use grade 11 work, but it was almost always a bit challenging to work around some questions. Lots of pieces of information were left hanging for the student to discover, or at least to appreciate. And a lot of planning, some constructions were necessary to move around. For you have seen my final examination paper in 2005. It's here in the channel. Check it out and see what was the difference in how matriculants were examined back then and now. Okay, now there's too much grade 11 work being asked and a little less matric related work that is asked. And for me, that's not good. Okay, we need to ask, even if it's a grade 11 question, but if we're asking a grade 11 question in metric, it has to be a higher grade question. We can't ask you to reproduce what you've done last year. and maybe grade 10 as well. No, if we're bringing a question from those years, it has to be a higher grade question because you are now in metric. We can't expect you to repeat stuff, right? So that's where the weaknesses are essentially in our curriculum. Not to say it's weak entirely, no. But I think when we're asking a question from the past, it has to be a higher grade question because you've gone through those questions already. So we're just throwing marks in your direction and claim you're doing well. No, the grade 12 questions, for me, they should be a mixture of standard grade and higher grade questions because this is new stuff for you. And definitely you may struggle to put up with some challenging areas. So perhaps a mixture of higher grade and standard grade questions, and ones that fit both categories are best to ask. But if we bring a question from the past, it has to be a killer because there's no way we can ask you the same thing that you have done already and passed with flying colors, and we repeat it and we say you are smart. No. That's wrong. And unfortunately, politicians only want to produce good results and claim the nation is doing fine, which is ridiculous. But they say this because they just want votes, isn't it? For them, it's just for survival in the political arena, where they would not survive if people were upright and focused. But now, yeah, we have people who are just going through the motions. Anyway, guys, let's stop the nonsense. Of course, folks, in the exam, it helps to skim and scan and see how many of these questions can you answer straight away and start doing so. And those that are challenging, do you have a plan? Now, let's see. Calculate the gradient of AD. We've got points on it. Determine the equation of BC in the form. Again, the gradient of AD helps us there. We can get the equation in the standard linear format. So again, prove that BD is perpendicular to AD. BD is perpendicular to AD. So this means we multiply the gradients, and if they give us a -1, so therefore that would be the case. Great. Now we can answer that question. Calculate the size of BDM. BDM. So this is the angle of inclination of essentially BD. So we would have the gradient from above. We use it, so it's easy. Now, if it is given that TC is parallel to DM, okay, let's see. TC is parallel to DM, meaning this is a horizontal line. Okay, now I can make a nice construction here. Maybe let's remove this point on this side so that we can make this construction nicely. All right, so that's what we are being told. So sometimes I like to do this. This is how I approached my exam, guys. You may not have to do the same thing that I'm doing, but yep, it helps a lot to somewhat do things in a manner that makes the understanding of the subject great. Okay, so those are the issues that we're being given right now. Now, endpoints T and C are symmetrical. Do you hear that? Symmetrical about line BM, meaning they are mirror images. Okay? Of each other about the line BM. So what does this mean? It means this distance, T, whatever this point is the same as that distance. All right, so nice and easy. So can you see issues of symmetry? So it means whatever we want to call this point when But this was an imaginary line, so to speak, so we're not going to want to waste our time saying it. But all we know is that we need the coordinates of t, which we already found is 3 and 5. So we can see that from 8 to 3, that's 5 units. So this is going to be 5 units. Right? Now, this would also be 5 units. Right? Right. So now we no longer need simultaneous equations to get the coordinates of C, because all we are going to do, we just simply move this point across. Remember, the y value for a horizontal line is the same. So y here is going to be 5, which is the coordinate at t. But the x, we're just going to move it 10 units more. So 3 plus 5, that's 13. Nice and easy. So can you see, guys, as we work along, we see that with extra information, which we appreciated, that yes, we did have a plan, but now this makes our lives a lot easier. So take a moment and work through these problems. You will be the best. Trust me when I tell you this. You will be the best. Anyhow, let's move on. Calculate the area of triangle BDF. So there's that triangle that we're trying to solve. All right, so how will we do this? Well, this is easy. This is a scalene triangle. And this line is already perpendicular to the basal side, because remember, this is the base, that BF is the base, and we can see that this is a vertical line, so it's going to be the difference of that value there and this value. So that gives us the basal side. The height is going to be from D to M. So that's again 8 minus 2, that becomes 10 units. So that becomes the height. So we can work everything out. Again, this is a higher grade question. Both of these two, they are not really that simple for an average student. So can you see, guys, taking time to plan, we can see we're taking these marks with ease. All right, so let's go for it. The gradient of AD is equal to y at D minus y at A divided by x at D minus x at A. So this is equal to y at D is 0 minus 6 divided by x at D, that's minus 2, minus into minus 8. Okay, so let's see, this is a negative slope, so this is minus 6 divided by 6. Okay, because this is going to be minus 2 plus 8, which is 6. So minus 6 divided by 6 is minus 1. Okay, nice and easy. So that's easy. All right, so for this one, it's just easy, 2 marks, substitutions, and the correct answer. So, 3.2, we need to determine the equation of BC. So we know that the gradient of BC is equal to the gradient of AD, which is going to be equal to minus 1. Why? We know that these are parallel lines. Parallel lines have equal gradients. Sometimes we may write given, maybe let's write it better. We will say given that AD is parallel to BC. That's why. Okay, so what are we going to say? We will say then, we know that BC as a line will be such that y is equal to minus x plus c. Now through point B, where we have x as 8, y as 10, we know that 10 is going to be minus into 8 plus c, therefore our c is 18. We can safely say therefore y is going to be minus x plus 18. And of course we can see that if we have 10 as a y value at b, where it cuts is going to be definitely much bigger. So this line makes some sense, although we know the diagram is not drawn to scale, so we don't want to read too much into this, but we just want to work our business nicely. Oh, this table makes noise, guys. I apologize for that because I move a lot. I'm one of those people who have what is called an increased psychomotor activity. So that's the first mark there. This statement and its reason. This substitution gives us the extra mark. And the final finish is how we score those 3 marks. Usually very easy stuff. We need to move on. Okay, so we have 3.3. We need to prove that BD is parallel to AD. Of course, we already have the gradient of AD. All we need is to find the gradient of BD. But what I'm going to do here, I will just say, well, this is very easy. We can just say MAD times MBD is equal to MAD is minus 1 into this one. I'm just going to rush in and not waste time. So y at B is 10 minus y at D is 0 divided by x. There is this one plus 2. So indeed we get minus 1. So we can say therefore MAD times MBD is essentially minus 1. We can say therefore AD or BD is definitely perpendicular to AD because the product of their gradients is minus 1. So meaning these are inversely related to each other because that's 1, isn't it? 10 divided by 10 is 1. Now, this is great. So obviously this is a calculation on its own. Lovely. And this business right here, demonstrating that the product of the gradients is minus 1. The conclusion is already there, so there's no mark for it. Nice and easy. Move on. So 3.4. We need to calculate the size of BDM. So this is easy. BDM. Can you see? That's just 45 degrees. But we need to show because the question says calculate, not write down. So we respond according to the instruction. So we know that technically the angle that we want, we know that 10 of this angle BDM is going to be the same as the gradient of BD. Right, it's as simple as that. So this implies that the tangent of BDM is equal to 1 because we can see that from this calculation that's essentially 1. So we can say therefore BDM is the arctan of 1, which is 45 degrees. Perhaps too many conclusions don't really look attractive, but it doesn't really matter, guys. Remember, this is where you do your own thing. Don't be too fussy about certain unimportant issues. But for me, the build up to the final big furious conclusion has to be smooth. Okay, so again folks, this substitution here is important in the final answer, right? So that's how we score those 2 marks. No manga business here. We need to be very, very, very strategic on how we do things. Now let's deal with the big boys and girls, but they're not too big for this question, so that was a fair exam, I guess. Now, if it is given that TC is parallel to DM, so meaning it's parallel to the x-axis, nice, T and C are symmetrical about the line BM, so that's the story. Calculate. Can you see the question says calculate, so we can't just write. We cannot just write the coordinates of C. So now we need to be a little bit nicer to the examiner and give them the facts they are looking for. So what are these facts? We need to essentially show some calculations. We can't just rush in. And we can see that there's 3 marks only here. But we don't know the coordinates of T. Of course we do, but we need to justify them. Once we get those coordinates, we need to at least say something about this point right here. So I'm thinking we need to say a lot of things. We're going to say, fine, let what do we have here? A, B, C, D, and then we've got F. So maybe let's call that point E. So let's say let E be where TC intersects BM. Be my what? Oh, that's not BMW. Be my wife. Such that we know something. Okay, let's not be too much, but I want us to be too much. Let's say such that we will appreciate that X at this point E is going to be the same as X at T. And we also understand that Y at E should be the same as Y at T. Because that's a horizontal line. We can just easily say TC is a horizontal line. Okay, so TC is a horizontal line. I don't know if it is necessary to say these things, but now we're going to say but. Right? We also know, okay, let me say something. Also, okay, maybe let's put it this way. Also, we understand that X at E is the same as X at B, right? Because we didn't really speak about M as yet, and I don't think we need to for now, right? For now. So we can leave it at that and say X at B. Again, what is this? We can say BM, say BF. Okay, let's just say BM is a vertical line. Now, I don't understand this question for it to be 3 marks because there's so much to say. Okay, so now we understand what we want, but now we need to say some things that matter. What is the coordinates of t? We will say however. T is such that we have 8 minus 2 divided by 2 is 2. 10 plus 0 divided by 2. So therefore, t is the point. This is 6 divided by 2, which is 3. This is 10 divided by 2, which is 5. Okay, now that is good. That is good. And what does this conclude? It therefore concludes also that E is going to be the point 8 is to 5. From the statements above. See, we made some nice statements. Now they come into effect. Because we need this point. As much as I didn't see the need to include it, but let's write it differently to show that it is a necessity to call it in. Now, can you see, guys, there's just a lot to say. But again, I suppose, but if the question says calculate, we can't just jump in and calculate without showing how we did things. Of course, why do we do this? Because we know that t is the midpoint of BD. Nice and easy. That's why we do that. Of course, I'm being too much for 3 marks. I suppose it's whatever. Yeah, this question is nasty. So we can say then, sometimes this is a way an examiner can hide the fact that the question is complex. Maybe. Because if the instruction is to say calculate, if it said determine, we could say by inspection, but again, what are we inspecting? There's a lot to say. There is a lot to say. So, all right, let's just move on, guys. Then, what do we know? We understand that the coordinate of C, okay, I want us to work it out nicely. Of course, here there can be many ways to deal with this issue, but I'm going to say then C will be such that, actually now I don't need to do too much. C is going to be such that, what do we have? We are going to move this point by taking the x value there and add this distance doubled. So we are going to say this is 3 plus, okay, maybe let's just show it nicely. Superb. So this is 3 plus, now, okay, I think I'm doing a bit too much. So this is going to be 3 plus. Now we work out this distance. This is going to be x at E, which is 8, minus x at T, which is 3, times 2. Because we are going to move this distance and again move it the second time. So we want to double this. So I don't know, guys, how this is accepted. But when I see now, I have a lot to say, but I don't have many marks to score. I just move on. And of course, the y here is going to be 5. There's no question about it. It's a horizontal line. So the y value there is the same. So we can say therefore C is this point. Now this is 5, 10, that's 13 is to 5. Okay. I think we have shown some form of a calculation. Although we may have not really explained much, it's not a big deal. I think our coordinates here came in handy. Of course, one may have wanted to write these out, say x at t plus 2 times x at this minus x at that equal to y at that. What I mean here, one could easily write a formula before the substitutions. Let's just do it for completeness sakes, because I know, guys, you will say I'm the one who taught you to be hooligans, and that's not me there. So we can say then C is such that x at t plus 2 times x at e minus x at t is to y at t. Right. Now that's good. We are done. Maybe we can finish a very weak reason and say TC is a horizontal line. Okay, that's a very weak reason, to be honest. Is it necessary? Maybe. No? Whatever. So that sounds right to me, because we are showing the structure that we did. We were just trying to show that this portion gives us the x coordinate and the y coordinate is as we see it. Okay, not a big deal. So as you can see, guys, this is also good, yes, but it's also a lot of work. We already determined the equation of this line, but this would have forced us to find the equation of this line too. And if we did find the equation of this line, then we solve simultaneously. That's more like the amount of work we are doing, essentially. So yeah, whatever, guys. Here, even if you ignored this whole shenanigan, we could actually work out those coordinates by using simultaneous equations, but this would have forced us to find the equation of this line, which is about a lot of work. I mean, just maybe same amount of work, because we don't know the gradient of df. We also would need the equation after that, then solve simultaneously. So that looks more or less the same amount of work. Okay, so not a big deal. So you can ignore all of this and do it that way. But I'm just trying to respond to this piece so that you need to know how to use what is given, because sometimes it's the only way to solve a problem. All right, so let's get to 3.6. What on the Lord's earth is going on? Now 3.6, we did not mark. Yeah, these 3 marks, guys, are ridiculous. First and foremost, this coordinate is important, that coordinate is important, and yeah, doch, everything else doesn't seem to matter. I wonder. Of course, the memo will just come up with this and this and this. All of these other steps would be missing, and you wouldn't understand where all of this came from. But from a student, I would expect this attempt at least to show that indeed the student understands. Now we're going to go on and say in triangle BDF. Okay, so we are happy with this triangle. What are we going to say? Look, there's 5 marks on offer here, so that's quite a lot of marks. So this means we need to showcase most of the things we need. But for me, I don't really mind. We can just write it nicely and say, well, the area of triangle BDF is going to be half. The basal side is going to be BF multiplied by the perpendicular height, which is going to be DM. Because this is a scalene triangle, so the height is outside the base, okay, or outside the triangle. As long as one can spot this, very nice and easy. So there's no need to explain anything here. So this is a half of, now BF is going to be y at B, which is 10, minus y at F. So this is 3 by 3, that's 9. 9 plus 1, that's 10 over 3. Right? Because it's a vertical line. So we just take the difference, of the y values into dm. Again, we need to find out, or we definitely need the coordinates of m. At some point, we need to state that m is this business right there, without this. So we need to state that m is 8 is to 0. This one is by inspection. There's no need to explain it. So great. So now dm is a calculation on its own. It's going to be 8 minus 2. So it's going to be 8 plus 2. Okay. Nice and easy. So we get our answer without wasting time. So we've got 0.5 into 10 minus 10 divided. Ooh, I didn't go back to the normal mode. So 0.5 into. So certain notations, once we're on stats mode, become a little difficult to work with. So we've got 8 plus 2. So I'm getting 100 over 3. This is equal to, sometimes we use the approximate sign because now we're going to round off. So this is 33,3 square units. Okay. Nice and easy. So can you see, guys, once you work on the diagram, you analyze it well, these 18 marks become a piece of cake. Of course, coordinates of m become important. This is a calculation. This is a calculation. The entire substitutions and the final mark. Remember, the units must be in the right situation for the final mark to be scored. So this is nice, easy 5 marks. So obviously, guys, this is a very easy 18 marks, which I believe students should take with a big smile, because there's nothing here. Okay, let's rush through to question 4. Now this is a typical grade 12 question. Yeah, my desk is making noise, folks. I cannot help it, so you will forgive me for the noise. Now let's just rush in. A circle having C with coordinates 3 and minus 1. Is it shown? Yes. As center. Okay, it's very important to note that this is the center and a radius of 10 units. Okay, great. So this means TC is our radius, and we see that it's 10 units. Nice and easy, indicated. All right, is drawn, so we see it. Now PTR is a tangent. Now we've got a tangent here. So PTR is our tangent. So what do we know? The tangent always meets the radius at 90 degrees. So this tells us that we've got 90 degrees on either side, because angles on a straight line will effectively give us that. So we've got these right-angled triangles. Nice, nice, nice. All right, great. So at t, of course, right? Now r, remember that k value, once it's a variable like that, it needs us to find it out. So that's a potential question with that 21 as the y coordinate. C, again, C and P are vertices of a triangle. Okay, not a problem. We see that there is indeed a triangle, which is this one, I hope. Or it could be the big one. So when we say a triangle, we're not specific, right? But we can see it's either this or the big one. TR is 20 units, okay, indicated already. So these are 20 units there. So usually with the grade 12 question, there's not much information that usually gets given. We normally just have to deal with the issues ourselves. Now the question says, how will we find R? Sorry, the coordinate K there. How do we find that? Okay, so this is very strange, a little bit strange. But if we look, we have a right-angled triangle there. So if we look at this right-angled triangle, what can we see? We can work out the length of RC using Pythagoras, since this is going to be 90 degrees. We've got that side, got this side, then we can work out the hypotenuse side. And from the hypotenuse side, we can substitute into the distance formula these points, and we will have the variable k. So that would be easy. We can easily do that. So that's how we can find the value of k. Of course, we're going to get two values of k. We need to choose the positive one. Otherwise, the other value of k would be directly, look, this would be symmetrical about this c, so the other one would be a negative one. Okay, so that's a big question, as we can see, that this becomes a big question. But we can deal with it. So, is there anything else? What about the coordinates of t? Well, we already know the distance here, but now we've got two variables, x and y. We don't know those. So this becomes a little bit challenging, but simultaneous equations, obviously, where we can use the distance formula here to derive something and then represent it in terms of one variable. We do the same, derive an equation between r and t, using that to get the other equation, and then we substitute, we would get the coordinates of t, but we would have to be selective as well, because the x coordinate needs to be negative as opposed to the opposite one that would be over here, which is positive. The y value should be positive as opposed to the one here that would be negative. Okay, so that's just the idea. So again, that would be a big question to find the coordinates of t so far. And then what about the coordinates of p? Well, if this line is parallel to the x-axis, and we can see that these are tangents from the same point P, so it means this length TP should be equal to PS. Because this looks like a tangent at S, but nobody said anything. So again, this is too much for now to think about it. But in any case, why do I know it's a tangent even though it is not yet said? It's because if I draw a line from center to S, seeing that this line is parallel to the x-axis, it should be perpendicular to the y-axis. Right. But now, do we know that this line is perpendicular to the x-axis? We don't. Okay, maybe that's jumping the gun a bit, but this is just a bit I get. But let's just park the bus there a bit. So, well, this is again suggesting something like that, but nobody said anything in the given statement about S. Okay, so this is very, very, very important. So we need to think about it, but be ready to rub it off if it is not the case. But that's the suggestion I am getting. Okay, so that's fine. So this means, we need more information to work out the coordinates of P. There's a lot. Of course, with the grade 12 question, most of the extra information gets asked as we go along. So some clues are going to come in. So we can clearly see we need more information for P and S, because all of what we're doing, we're not so sure at all. One thing for sure, this looks like a tangent. I would believe it is, but it hasn't been stated as such. All we know is that this is a horizontal line. This means if we get to know the coordinates of S, as in the y value at S, it will be the same as the y value at P. That's all we can say. As for the x coordinate, it's another story for another day. Anyway, let's move on and start answering questions. Of course, this one, it's best to just answer each question as we go along, because everything we get is going to lead to the next. If at all it doesn't, extra information will be provided. Okay, let's start. 4.1. We can see there's not much, but there is enough, of course, for us to use. Give a reason why TC is parallel to TR. Sorry, perpendicular to TR. Okay, this is easy. The tangent is always perpendicular to radius. Right, that's it. 1 mark. 4.2, we need to calculate the length of RC. Leave the answer in set form. Again, a very easy question. So we know that in triangle CRT, okay, some people, they call this one capillary refill time. Oh my God, to check if someone is dehydrated or shocked or whatever, the pulse is effective or not. Anyway, in this triangle, it's a right angled triangle because this statement is already giving it to us. So we understand that basically RC squared is going to be equal to TC squared plus TR squared. This is from the theorem of Pythagoras. So this implies that RC squared is equal to TC is 10 squared plus TR is 20 squared. Therefore, RC is going to be the square root of 10 squared plus 20 squared. What is that? Okay, that's going to be 400 plus 100, that's 500. So square root of 500. So luckily our calculators do a very nice job of putting this in simplest said. Why is my 5 looking crazy? Okay. Everything just wants to look naughty. Okay, that's it, guys. Easy, easy, easy. So as you can see, we knew that we would have to calculate that length if we have a chance of calculating the value of k. Now, which is the next question. Can you see the questions sort of lead us into where we needed to go? We already figured it out, but it's nice to see that indeed what we had in mind is what the examiner had in mind. So it says we need to find the value of k if r lies in the first quadrant. Okay, because we know this is not necessarily drawn to scale, but of course the diagram suggests as much. Okay, we need to do it. So what do we know? We know that rc squared is going to be equal to 10 root 5 all squared, isn't it? Yes, which implies, now using the distance formula, x at r, that's k, minus x at c, which is 3 all squared, plus y at r, that's 21, minus y at c, it's minus 1, which is going to be plus 1 all squared, equals, this is going to be 500. All right. So this implies, well, I think we need to just keep this one as is instead of expanding. It's going to be dangerous. So we've got 500 minus 22 squared. Okay, right. What is this? Sekisetine. I knew it. That's why I kept this one. So we do the inverse operation right here. Okay, what we do there, I don't know why, man. My writing is always horrible. What we do to the one side, we must do to the other. So this implies that k minus 3 is plus or minus 4. So therefore we need to find the actual value of k. Remember, when this is positive, when we transpose this, k becomes 7. And that's what we want. And when this is minus 4, when we transpose this 3, we get plus 3 minus 4, which is minus 1. So it cannot be negative. So k being 7 is better. So we need to choose the correct one. K is an x coordinate in the first quadrant. It can't be negative 1. Okay, as we can see, wow, this is 3 and not so far from there. It's 7 already. Yeah, this means this diagram is crazy. Okay, as crazy as it is, this is not a big deal. How do we score marks, guys? Substitutions into the left-hand side, and the general substitutions is where the marks are. And then working out here, we get the third mark. Where is the fourth? I don't know. So maybe 2 marks for the answer, whatever. So let's move on. 4.4. We need to determine the equation of the circle having center C and passing through T. Right. We need to write the answer in this format. So this is easy. So we know that the circle C is x minus the x coordinate at the center plus y minus the y coordinate. There's going to be y plus 1 all squared equals. Now, r squared, remember the radius is 10, so 10 squared is 100. So this is as simple as that. So left hand side, right hand side, easy 2 marks. 4,5. We are told PS is a tangent. Can you see that statement we were waiting for to the circle at S? Now we are free. Is parallel to the x-axis. Do you hear that? Nice and easy. So we saw this, but we were kind of doubtful. Okay, so Now, everything we've said makes sense, because if this is parallel to the x-axis, it will be perpendicular to the radius. Now, if this is to be perpendicular to a horizontal line, this itself is a vertical line, so it must be parallel to the y-axis. So this means the x at C is the same as x at S. But now the only question now is the y value, because we don't know what this is. But we can work it out. Why? Because we have enough information. Look, this radius is at -1, and we know this length is 10 units. It's the radius. So if we move -1 10 units down, what is it? So -1 minus, remember when you're moving it down, we're going to subtract. So -1 minus 10 is going to be -11. So those are the coordinates. Those are the coordinates. Nice and easy. Okay, so we may be asked to find the coordinates, or the question says we need to determine the equation of PS. Of course, this was the key. Now, when the question says determine and it's 2 marks, an answer only is good enough, okay? But I do believe we need to first state the coordinates of S, and from there we write the equation. Without the coordinates of S, we are going to have a bit of a problem. All right, so here a determination is by any means necessary. So we can say S is 3:2 minus 11. How we got it, nobody cares. We can say therefore PS is such that y is equal to -11. It's a horizontal line. Okay, I'm sure you saw the process. A 2-mark question, we don't need too much. Coordinates of S and the equation. Nice and easy. Now 4.6 says the equation of PTR is, can you see, we needed lots of extra information. PTR is like this. Again, it's given in the expanded form. We need to sort it out. Now we need to calculate the coordinates of P. Very interesting, isn't it? Yeah, because what do we know about the coordinates of P? We have some x, but the y value is the same as the y value at S, because that's a horizontal line. So all we need to do is just to say in this equation, when y is -11, what is x? And we are done. So this becomes very easy. So we have 4.6.1. Well, we know that P is such that 3 into -11 minus 4x is equal to 35. We just substitute here easily. So this implies what? That minus 4x is equal to, and that would be -33, right? -11 times 3. Now we transpose that, we get 35 plus 33. It becomes 68. You can say therefore x here is going to be minus, so we divide this by -4. We get -17. Okay, as long as it is a negative, I'm happy. So we can say therefore point P is going to be -17 is to -11. Okay, not a bad question. Very nice question. Very, very interesting. But perhaps to stop being hooligans, let's say x, y at P is going to be y at S, which is equal to -11. You can say PS is a horizontal line. Okay, nice and easy, and this implies that P would be the way it is, and we make the conclusion. Great stuff. But maybe let's move these dudes so that we don't end up where we don't like it. Okay. Yeah, hey, sometimes I'm getting caught in my own issues. Okay, let's just do it. Okay, it looks a bit better. Although there's no need for what I'm doing right now. Okay, let's move on, guys. We're losing time. We need to calculate giving a reason the length of PT. Okay, we need to calculate giving a reason the length of PT. So how are we going to calculate the length of PT? How is this possible? It is possible because we are going to use this triangle. So we're going to use this triangle. Why? Because we know tangents from the same point are equal, as we indicated, and these are congruent triangles essentially. Because if we look at it, we've got the radius, that's the side, we've got the right angle, we've got the hypotenuse side, which is common. So they are effectively congruent. So if we find PS, we have found PT. So very interesting stuff, isn't it? Yes. So we definitely have a way now of calculating the length of the side PS. It's horizontal, so it's going to be x here minus the x there. And mind you, we found this as minus 17. So that's easy. So we're going to use this triangle and then take it back to that. That's where the reason comes in. Tangents from the same point. So we're going to say in triangle CPS. What do we see? The right angled triangle. So we can use Pythagoras here. Oh no, we don't even need this one. Lord, we don't need the triangle. There's no need for Pythagoras here. So we just need that line. All right, so we can just simply say PT is equal to PS. These are tangents from a common point. Maybe let's write it that way. From a common point. Okay, that's it. So this implies that PT will be x at S minus x at P, because that's a horizontal line, which implies that PT is going to be 3 minus into minus 17. Therefore, PT is 20 units. Okay, so the Pythagorean theorem is not necessary unless we wanted PC. So easy. So obviously here we're getting a mark for the statement and the reason and the final answer. Remember, the units need to be there. And here I didn't mark this one. So this is very important, by the way. How many marks were being scored for 6.1? 2 marks. Okay, great. Everything is sorted there. The point doesn't really get a mark, but the work. This table is making the noise that irritates me. Now let's look at 4.7. Okay, we're losing time, guys. Consider the circle with this equation having center M. Okay, write down the coordinates of M. So this is very easy. 4.7.1 M. We'll take the opposites of those. It's going to be 3 is to minus 16. Okay, we just take the opposites of those values inside. Nothing more. That would be the center M. Okay, 4.7.2. Write down, again the question says write down, so we just do so. The length of the radius of the circle, that's going to be the square root of 16, which is 4. So we know that the radius is going to be equal to 4 units. Again, easy marks here. So 4.7.3 says prove that the circle with center C and circle with center M do not intersect or touch. Now this is a higher grade question. So you may want to do it, you may not want to do it. After so much that we have done, how will we know that these circles meet or do not meet? Well, this is interesting, is it not? It is. It is interesting. So, we need to check something. We have the center at 3 and minus 16. So, oops, we don't know where this is. I mean, if we're already at minus 11 at S, minus 16 is probably somewhere here. So let's just draw ourselves a nice circle. Of course, this circle must be 4 units in diameter or radius, whatever. So 16 to 11, so that's a lot, eh? 16 minus 11, that's like 5 units. So yeah, it's going to be definitely below this point. Okay, guys, now this one is not going to be as nice as I want it to be, but I'm going to try to make it look so nice. So this is the circle that we need to imagine now. And we can clearly see these ones would not touch because the radius is definitely short. From this point to circumference, it's not going to meet this one because this is at minus 11 vertically. This one is going to be just 4 units vertically, so it's not going to touch. But we need a mathematical way of proving this situation. So that's the M, the center of the circle. Okay, how will we prove it? Obvious. If we take the distance between the radii and is longer than, remember this is 3 is to minus 16, and if the distance between the radii is greater than the sum of the radii themselves, then it clearly proves that these circles do not touch at all. Okay, so we just do it. It's a simple question. Once we picture it, once you work it out a bit, it becomes easy. So we know that technically CM is going to be the square root of x at M, maybe, which is going to be, I forgot. This is just a vertical line. Okay, maybe we don't want to put it that way. Let's just say, yeah, it is a vertical line. Why? Because the x at M is the same as the x at C. So it's a vertical line. I don't even need to do this square root business here. It's a waste of time. So it's going to be minus 1 minus minus 16. So it's going to be minus 1 minus minus 16. Therefore, CM is 16 minus 1, which is 15 units. Okay, so let's see now the radius. So let's see also, we know that the radius of circle center M, maybe let's just write radius M plus radius C is going to be 10 plus 4, which is equal to 14. So therefore, not V but R, M plus RC is 14 units. Can you see this distance is greater than that? We can say therefore CM is greater than RM plus RC. Therefore, the circles do not intersect. All right, so that's it, guys. That's it. So this one was not a big question, honestly. Everything was built up nicely. So as we can see, nobody asked us the coordinates of T, but yeah, it was something to think about, you know. Anyway, so how do we score the 3 marks here? First of all, calculating CM, the distance between the centers of the two circles, calculating the sum of the two radii, and this conclusion right here. Right. So this is good, because this is just the logic behind all the BSA. That's the work, man. That's the work, man. All right, folks, this is it. So if nothing didn't go any bad here, I'm feeling a little dizzy. So we would have scored those 21 marks. As you can see, guys, this analytical geometry thingy tends to take time from a student because there is a lot of analysis to do and a whole lot of work to put in. But as you can see, if we just do our work nicely, not panicking, you know, just taking our time, we score a lot of marks. Obviously, I took the liberty to explain a thing or two. This should be second nature. By the time you sit for these November exams, was it November? When was this? Wow, it doesn't show. I got this copy from essay exam papers. I don't remember. Was it November or May, June? Sorry, May, June. So by the time you write these kinds of exams, folks, you should already be knowing your way around here and knowing exactly how to take precautions, how to walk around here. This can be done. I mean, question 1, let me just tell you straight up. Question 1, 2, 3, they can be done within the first hour. In fact, when I say within the first hour, all of them finished within that first hour. Because trust me, it would take about 10 to 15 minutes first question. Same for question 2, that would be 30 minutes. This could take minimum 15 minutes as well, that would be 45, you know. Then some portions of question 2 could be chowed within, question 4 could be chowed within that time frame, maybe a spillover into, you know, the second hour, a portion of the second hour. Then we get to trigonometry, which we need to finish by the second hour. We need to finish it by the end of the second hour. Then we can dance with Euclidean geometry after that. Okay, let's get to this easy stuff. Okay, quickly, I don't want to waste time. Now question 5, we're given that in the diagram PR is perpendicular to TS, an obtuse triangle PTS. Okay, great. PT is root 5 indicated, TR is 2 also indicated, PR is 1 unit indicated, PS is square root 10, and RS is 3 units. So all of these things are done nicely. So it says write down the value of sine T. Okay, that's easy. 5.1 with 5.1.1. And here we've got a sine of angle T is going to be equal to, now we are working on which triangle? We are working on this triangle. All right, easy. So this is going to be opposite of hypotenuse. So this is going to be 1 over square root 5. No questions about it. So I don't know why these questions are there. Cos of S. Cos of S, we are working on this triangle. And we can see it's a right angled triangle. So cos of S is going to be adjacent over hypotenuse, which is going to be 3 over root 10. Okay, so not a very difficult question also. We move on. So these were just easy marks. 5.1.2, perhaps this is going to be the key higher grade question. As you can see, the marks are a lot, so it means we would need those two guys. So let's calculate without using a calculator the value of cos of that situation. Cos of T plus S. So we can see this is a compound angle identity now that we will need to sort it out. Okay, let's go on. This essentially is going to be cos of angle T, cos of angle S, minus the sign changes to sine the first angle times sine of the second angle. Now we know that cos of T is going to come out from this triangle. Right. Now what is cos there? Cos is adjacent over hypotenuse. So that's 2 over square root 5. Into cos of S, we already found it. This is 3 over root 10. Minus sine of T, got 1 over square root 5. Into sine of S is going to be opposite, which is 1 over square root 10. Okay, so without using a calculator, numerators multiply. This is 6 divided by root 5 times root 10. This is the same as square root 50. Minus 1 over square root 50. So if you don't know the laws of sets, you are a dead student. Now we need to find the common denominator, which is easy. It's root 50. So this is going to be 6 minus 1. So this is 5 over square root 50. Okay, that's fine. Not a big deal. So, do we really have to do anything here? I doubt we do. So we can leave this here. In metric, guys, we don't need to rationalize the denominator at all. Sometimes, if you do, you need to show how you did it. Okay. Sometimes it may force us to show how we did it. So this answer could still be written as square root 50 over, that would be 50 to 5, that would be 10. Ne? So that could come out as such. So, however this answer is presented, but essentially there's no need to rationalize. If you do, please don't show up with the answer. Show us how the process was followed. Anyway, guys, every time we use compound angle identities, we show it. Right, this one was not given to us. So that was some form of a determination, and the other one was also some form of a determination, and we can say the general instructions. Can you see? Nice, 4 marks and the 5th mark. Good. Not a very difficult question otherwise. Interesting, actually, because we hardly get these kinds of questions. But yeah. 5.1, pretty interesting, but standard stuff. Nonetheless, okay, let's do 5.2 right here. Now we have a situation, our nice simplification here, determine the value of. So this is good, so we've got 1 divided by cos of 360 degrees minus theta times sine of 90 degrees minus theta minus 10 squared 180 degrees plus theta. Okay, this one looks easy, so this is equal to 1 over, we do the reduction formula, cos of 360 minus is as good as cos theta into sine of 90 minus is also as good as cos theta using cofunctions, minus here 10 of 180 plus is just 10 theta, but then we square it. Easy. So this is equal to 1 divided by, this is going to be cos squared theta minus 10 squared theta. Alright, so let's just follow the process, no need to rush. Cos squared theta minus 10 squared theta, the same as sine squared theta, divided by cos squared theta using the 10 identity. Of course, now this forces us to find the common denominator, which is cos squared theta. So this becomes 1 minus sine squared theta. And from square identities, this is as good as cos squared theta divided by cos squared theta. This is equal to 1. Okay, nice and easy. So this one again, pretty grade 11 stuff and standard grade material, nothing really higher grade here. Of course, there may have been a mistake. We go back. Remember, these are not marks to lose, guys. These are marks to score. We just decide to give theta some value. Let's give it 2 degrees. Now we just put it on the calculator just to prove if everything we did is right. So we have 1 divided by cos of 360 degrees minus 2 into sine. Now here be careful of brackets. 90 degrees minus 2. So we need to be careful of our signs here. So we go on and say minus the tangent. Okay, now here we need to be careful how we do it. So it's going to be minus, take a square. We're going to say the tangent of this angle 180 plus 2. But remember, this one must be squared. So brackets are a key factor here. So I'm getting 1. So this means our simplification is good. So now what do we do? This reduction is good. That reduction is good. That reduction is good. Okay. That's very important. Using the 10 identity, that's good. Using the square identity, that's good. And the final answer, how many marks? 1, 2, 3, 4, 5, 6. So that's good. We move on. So 3-step approach. If you don't know it, good luck with failing. Good luck with failing, because you are going to fail if you don't know these things by now. Anyway, if sine x minus cos x is equal to 3 over 4. So let's deal with it nicely. So this is sine x minus cos x equals 3 over 4. Calculate the value of sine 2x without using the calculator. So this means now we know that this is a double angle of sine. But now we've got single angles here. So this is a bit silly and tricky. But now a matriculant who understands maths knows that technically this is more like SADS if you think about it. So how do we undo this? We square both sides. So if we square both sides, we're going to end up creating a situation for sine 2x in terms of identities, because this is binomials. So once we square this, we get a trinomial, which is going to give us a square on sine, a square on cos, same angle. That would be 1 according to identities. Then the 2 sine x cos x gives us sine 2x, and the rest is history. Okay, so again guys, inspecting these is key. If you do not inspect, of course with practice this becomes second nature, guys. Honestly, you will see when you need to do this. You will see when you don't need to. So we just square both sides. Remember, in maths we are allowed to do anything as long as we are consistent if it's an equation. So this is going to be sine squared x minus 2 sine x cos x plus cos squared x equals 9 over 16. Okay, easy. Now we can see that these are like terms because the angle is the same and the square identity tells us what we want to hear. So this is as good as 1 minus. By the way, this on its own, it's also a double angle identity for sine. So this is going to be minus sine 2x is equal to, forgot there's a fraction there. So this is equal to 9 over 16. Alright, so just transpose this to that side and this to this side. So this also implies that sine 2x is going to be 1 minus 9 over 16. Right. So we multiply 1 there, that's 16 there, that's 16. 16 minus 9. I don't want to think that's 7. So we can make a conclusion that sine 2x is going to be 7 over 16. Okay, that's good. All right. The last one is easy to handle as long as the business is good. But if the business is not good, you are a dead individual. So can you see we've got sine 2x, nice and easy. By just knowing what to do. Of course, here I was just using my 3-step approach in a flash. If you don't know it, as I said, you are a lucky individual to go and just fail in life for no reason. Okay? Doing this is a mark, right? Right. And then what do we get? Using square identity for those two, we get a mark. Again, double angle identity, we get a mark. And what else? Final mark. So how many marks here? 5. Hey, what the hell? What? Come on, guys. There's no way. I don't get it. I don't get it. Where's the 5th mark? Oh, well, maybe someone wants to reward a student for the expansion here, but this is a weak one. Honestly, the mark is for the expansion, but a weak one. Either way, guys, this was a very easy exam. I see. Hey. These exams have been gifts from God. Don't get it why students didn't pass so well. The later exams have been a bit naughty, but students passed in numbers. This shows, guys, that we are teaching well. Those of us who are pretending to be teachers, we are doing well. Okay, guys, let's leave that as it is. Okay, let's get to question 6. I need to sleep, because I'm working. I'm on duty today. So I must get some rest. But hey, we will see. And hey, my family, guys, is bereaved again. We are going to have a funeral this Saturday. So I don't know, guys. Classes are not going to be that easy. But I believe we should have a class today at 7. So that we can work, because I will have to leave I need to leave on Wednesday night because I'm tired. Okay, let's not say I'm tired. I will be tired because I'll be on duty tomorrow 24 hours and have to do some work also on Wednesday. We actually have a brain tumor to remove. I might have to take part in that surgery. We'll see. If we do, then it means my whole day of Wednesday is gonna be gone. So this means I need to leave on on Thursday morning, because Friday there's gonna be a lot of work. We are having the funeral on Saturday, so yeah. Let's have a class tomorrow. I will try to find a way of making it work. And on Wednesday, maybe let's try, because on Thursday morning I'm gone. So I won't be available on Thursday evening, Friday, and of course the entire weekend, because we'll have the funeral on Saturday. I'll have to come back on Sunday. Then be back at work on Monday. So we'll be pushing again on Monday. So let's work on some issues on Euclidean geometry for grade 12. Now the grade 11 lessons, unfortunately, guys, I could not finish because I wanted to take you through all these theorems and show you everything, but I think I can just compile some worksheets, give them in the group for you guys to practice, and then I will try to feature some nicer questions on the worksheets. Of course, when we find time to revise, we can still go back and finish up whatever was lingering. There will always be time. Believe me, there will always be time. We just have to use it. Unfortunately, I'm under a bit of pressure right now with all of these things happening, My emotions as well are all over the place. Sometimes I wonder how I still am able to keep my head straight. We had a funeral not so long ago. Now there's another one. Yikes. Life can be very unforgiving sometimes, but hey, there's people we love, and we know we're not going to have them forever. So we have to accept God's decision to pull them back to Him. Ours is now to remember them, for we will not have them ever again around us. That's sad, eh? Yeah, but perhaps for us, because we are the ones losing, those guys are resting from this nonsense of life, which is so difficult to put up with. All the nonsense flying around, people going all crazy, trying to be as stupid as possible. And the world's just turning on itself, Yeah. Anyway, let the foolishness flourish. It's its own time to do so. 6.1, determine the general solution of this. Of course, guys, there will always be a question on this business. General solutions. So let's do it. 6.1, we've got 4 sine x plus 2 cos 2x is equal to 2. So what are we supposed to do here? Obviously, we need to deal with that that double angle for cos. But now, since this is sine, we must represent this in sine so that we can create a nice trinomial to work with. So this implies that we have 4 sine x plus 2. Now, instead of cos 2x, we will have here 1 minus 2 sine squared x equals 2. Great. So this implies, now when we distribute here, we will have minus 4 sine squared x plus 4 sine x. So this is going to be 2 minus 2, that's 0. Wow. Okay, all right, okay. So folks, here we can just pull up a common factor, which is essentially 4 sine x into minus sine x plus 1 equal to 0. And then we will then say, therefore, this implies that sine x is 0, or sine x is minus 1, isn't it? Oskov. Is it Oskov or is it of course? No. It should be plus 1. Interesting. Yeah, it should be plus 1. So what do we say? We can say therefore x is going to be, okay, maybe we are rushing. Let's not rush. X is going to be the arc sine of 0 plus k 360 degrees, or x is going to be 180 degrees minus the arc sine of 0 plus k 360 degrees. Or the second one, x is going to be equal to arc sine of 1 plus k 360 degrees, or x is going to be 180 degrees minus arc sine of 1 plus k times 360 degrees, where k is an element of integers. So we can make the conclusions. Therefore, x is equal to, now let's have a look. This arc sine of 0 is 0, right? Yeah, 0 degrees plus k 360 degrees, or x is going to be 180 degrees plus k times 60 degrees, or x is going to be equal to arcsine of 1, that's 90 degrees. So this is going to be 90 degrees plus k 360 degrees, or x is, now the last one is going to be 180 minus 90, which is 90 as well. So oops, that is all. So we can say where k is an element of integers. So those are the general solutions to this problem. Okay, so that's not too bad. That's not too bad. So if everything is following nicely, we just do so. So whenever we use identities, so we used the double angle identity for cos, we moved on, and the rest, when we factorize, we get a mark. Nice. And each one of these general solutions, right? So this one has to be right, that one has to be right, this one has to be right. So we have 5 marks now. So that was 6 marks. Maybe both of these have to be correct for that extra mark. Well, you can consult the marking guidelines for the exact way in which marks are distributed here. Now we've got the graph of g of x equals minus cos 2x. Can you see we've got this one? So now it's just itself here. All right, so this tells us that the period is halving. So from 360 to 180. So this means we should see a cosine graph. Can you see? This is a full cosine curve that is inverted because of the negative. All right, so this looks like it nicely. So for minus 180 to 180. Okay, so that's good. So that's very easy, not too complicated. Now, the question says we need to draw the graph for this function. Where is it here? Okay. This is 2 sine x minus 1. If you think about it, remember 2 is the highest common factor in this equation. So if we divide throughout by 2, we get 2 sine x plus cos 2x equals 1. So this means we transposed this there, and then we transposed this there to get the two functions. So this is good. So sometimes certain things can be put this way, and a question is asked, and especially this question, sometimes this can be given together nicely there, and then someone is asked to solve here. And you're like, what? That would be the points of intersections of the two graphs, but this would not be so obvious. We can make this a higher grade question actually, and just give these two functions and say draw them. Then once you drew them, ask these questions, and then the last one we say solve for this using the graphs, and you'll be like, what the hell? Yeah, it would be the point of contact, because yep, that's the one. Okay, let's look at this one. So this function has an amplitude of 2, yeah, but we are subtracting some 1 from it. So basically the maximum here is still gonna be 1. Still gonna be 1. Okay, that's very important. The minimum is gonna be minus 2 minus 1, which is gonna be minus 3. So it's gonna be at minus 3. So we expect this graph to do that. Can you see the grid is already telling us what we are going to come across. What is the period here? Still 180, so nothing changes in terms of the critical values. So it's just the vertical stuff that is changing. All right, so we know that sine of 0 is 0. So 0 times 2 is 0. Minus 1 is going to be minus 1. So this is here. And then we go on. What would be the next one? 90. Sine of 90 is 1. 1 times 2, that's 2. 2 minus 1, that's 1. So we are here. But now we need to think about it. What would be halfway between 90 and 0? That would be 45. So perhaps let's think about it. Sine of 45 is root 3 over... No, it's 1 over root 2. 1 over root 2. Which is 0.7 some change. Do we really need that point? Yeah, perhaps we do. So let's see, because look, if the other function, now here's what you need to understand, folks. If the one function uses every little scale that we see, we must be faithful with the other function, or else the points of intersections might just not be representative. So we times this by 2, and then we get root 2, then we minus 1. So that would be perhaps 0.41. Okay, that's almost halfway. So 0.5, 0.4, somewhere there. Okay, guys, so be very faithful. That point may not look important, but if you miss that point, this graph can look crazy. Believe it. Okay, so there it is. Now this is the graph of sine shifted 1 unit down and augmented to some extent. Great. So this is now 90 plus 45. This is 135. So sine of 135 is a half, right? Yes. You're lying. Sine of 135. No, it's more like 45, right? Did I write cos sine? But it's the same thing anyway. Okay, it's root 2 over 2, and then we times this by 2. Get root 2, and then we minus 1. It's going to be the same issue. So this means it comes back to that value right there. Okay, guys, sometimes it may not be as accurate as I want. But yeah. As you can see, this graph is slid a bit. But this was supposed to make the gradients a bit biggish. Why is it not so steep? Wow. Okay. Whatever. Now, anyway, let's have a look. What else do we see? 180 would give us 0. So 0 times 2, that's 0 minus 1, that's minus 1. So we are here. Now the question is, where are the x and y intercepts? Where are they? Because these graphs don't seem to intersect. Where were we supposed to have an intercept? Well, this graph, because it's a bit naughty now, we're supposed to have an x-intercept at 0, and it did not happen there, because now everything is doubled. And then another one was supposed to happen at 180, but now this has been pushed down. So yeah, everything else has changed. So this is one of those graphs. Goodness, why are you doing this to me now? Thing. Because without intercepts, we are dead. But anyway, we will be able to solve this. It's not a big deal. Not at all. So let's just continue getting the graph as it should be. And then, what do we see? Heban. What is this? minus 2 minus 1 is going to go to minus 3. All right, let's see. We were supposed to have minus 45 there. So sine of minus 45 is what it is. Times that by 2, we get minus root 2 minus 1. So this is minus 2.4 this time. So this one is going to be minus 2.5, maybe 0.4 just before that. Okay, we try by all means to get it right. And we'll see that it's approaching this. Great. And then at 90, we would have minus 1. Times 2, it's going to be minus 2. Minus 1 takes us to minus 3 indeed. Okay. And then this should be going back at minus 135, right? Yes, 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 yes. Should be taking us back. Then at minus 180, this should have been 0. Right, so then we get minus 1. Okay, so our challenge now is finding the x-intercepts here. Where are they? That's where the challenge is. But at this point, do we really need them? What is the instruction here? It just says draw, and it didn't say show the x-intercepts. Okay, if that's the case, guys, I'm just going to draw the sketch. Okay, guys, so there is our graph. At least here there was no instruction that says we need to show the intercepts with the axes and what. If that instruction is given, then we need to work out those intercepts for this sine function. But now, at this point, they have not been asked. We're not interested. Now let's go back. The general solutions here told us that we would have some points of intersection between the graphs. We can see 90 degrees. We can see that when k is 0, at 90 degrees, these two graphs are equal. And that is true. And at 0 degrees, we can see that they are also equal. It's a common y-intercept. Because when we say k is 0, so for this general solution, 0 comes up nicely. And then 180 as well, when k is 0, they are equal at 180. So we can see this, here, nicely. And at minus 180. Remember, 180 and minus 180 is one and the same thing, literally. So that's good. Of course, this is when k is minus 1 on this solution. Because we'll have 180 minus 360, which is minus 180. So minus 1 works out also there. Okay, so that's good. We can see that it works nicely. So everything is well represented. So we can pretty much, sit with the conviction that our graph for f is good. We just label it and that's it. All right, so the next question says, write down the values of x for which g is strictly decreasing in this interval. So minus 180 to 0, so meaning on the left hand side. Okay, when is it strictly decreasing? It's from this turning point to that turning point. G is strictly decreasing. Of course, that means we're not going to include the turning points. So this is easy. To answer that question is going to be, we will say basically x must be less than 0 degrees greater than minus 90 degrees. Remember, those values are not included because at 0 there's a turning point, at minus 90 there's a turning point. So, okay, good. So that's it. Easy 2 marks for the values and the inequality. That's easy stuff. What did I do here? Oh God, I didn't answer properly. I rushed. Okay, so 6.2.1 x must be less than 0, greater than minus 90 degrees. Okay, 6.2.2. Lord, we just needed to draw the graph. Okay guys, focus. Sometimes when you're feeling tired, breathe a bit, drink some water if you have. So we can just say C graph. We've done it. Okay, nice. 3 marks. First is the shape, second is the y-intercept, because the x-intercepts are not really there, and the maxima and minima, or the end points. There's many ways of looking at it. So this one, we know that x must be less than 0 degrees, greater than minus 90 degrees. Okay, easy. 2 marks. So here we're getting 3 marks if all went well. 2 marks, 1 mark for the values, the other mark for the inequalities. So 6.2.3 says, write down the value or values of x for which this is the case. So we are saying f of x shifted 30 degrees to the left, minus g of x shifted 30 degrees to the left. We need to have that difference as a 0. So the question is, when is that difference 0 anyway? When is the difference between the two 0? Well, we see that this is happening here. This is the point where the difference is 0, right? Because they are equal. So we know that essentially f, whatever the value is, so say for example this is minus 1. So this is going to be minus 1 minus into minus 1 as well, because g is minus 1, which is minus 1 plus 1, that's 0. So this is this point. So we just shift this point 30 degrees to the left. So when we shift this 30 degrees to the left, it becomes minus 30 degrees. So this is easy. So you can just say x must be equal to minus 30 degrees. That's what it is. Because other differences are way bigger. See, the difference here has a size. Difference has a size, has a size, has a size, has a size. Up until here. Okay, now maybe we might have 2 points where this happens because the whole intervals are included. So perhaps we need to consider that too. And this one. Because that's the case. That is the case. Why am I leaving this one? Goodness. Yo, guys, there's many now. All the points of intersections actually. Because this means when we take the value of f and subtract the value of g, we would get 0. So we just shift all those points 30 degrees to the left. So the first one is no longer this one. Of course, we need this interval. Okay, if we shift this one 30 degrees to the left, it's outside, so we're not going to consider that. So it's going to be this. X must be minus 30 degrees, so we'll just say 0 minus 30 degrees. Or x must be equal to. Now the next one is that 90 minus 30 degrees is going to be 60 degrees. So this will be at 60 degrees. Or x must be, remember the question said it's either a value or values. Then this, when we shift it back 30 degrees, it's going to be 150. Wow, almost botched this one. It should be 3 marks then. But 2 marks? Why? Why? Anyway, so that's it, guys. Whether we got it right or wrong doesn't matter. For me, I don't know why it's 2 marks when there's 3 solutions, but I guess this is just designed to catch a student not to realize there's 3 solutions so that it's not too obvious. Maybe. Yeah, maybe it's like that. So guys, I don't know how those 2 marks are scored for everything, of course. So this means if everything went well, we'd be walking away with some very easy 13 marks. Of course, the trick here would have been, do you really need these x-intercepts? The answer is no. They are not important. This is why the instruction did not even cater for them, so don't worry about them, okay? Nice and easy. Now let's get to this 3D structure nicely. So we've got question 7. Yo guys, time. It's 3 a.m. now. I need to sleep, or else I'm gonna have problems. Okay, let's move. From point A, an observer spots 2 boats. There is the observer, B and C. So there's a boat at B and at C. Okay. B and C, okay, at anchor. I don't know what this means. Doesn't make sense. Anyway, the angle of depression of boat B from A, angle of depression is that. Remember, this is parallel to this. So this means also this angle must be theta, if that is theta. Okay. So the angle of depression of B from A is theta. So this is just to suggest that this is theta as well. D is a point directly below A. So if it is directly below A, of course this usually shaded is the horizontal plane. So this is 90 degrees, which is to show that this is vertically below. Directly sometimes means vertically below or vertically. A and so below A and is there or is in the same horizontal plane as B. Now this is the shaded region. Okay, so BD is equal to 64. It's indicated meters. AC is 87 meters. Now pay attention to the unit of measurement, because our answers need to have those units. All right, folks, so what are we going to do now? Well, we've got a triangle, a right-angled triangle. We've got one side, the hypotenuse side. We can work out the common side using Pythagoras theorem, and we can work out the value of theta using any trig ratio. Usually here cos is the best, but once we have this side, we can also use sine or even tan. Now, what about this other side? Well, here we don't have much. So if we have this side, we have the hypotenuse, we can use sine to work out the angle theta there, or beta, whatever that is. And from there, what can we do? A lot. We can work out this side using Pythagoras. And yeah, that's about it. That's about it. If we want this side, we may need a little bit more because we don't know that angle. So there can be some extra information given for us to find that angle, and many other things that can be asked. So let's see. Calculate the size of theta nearest to the nearest degree. So we know that this is the triangle of choice. So we're going to say, okay, 7.1 in triangle A, BD. Please, guys, direct someone who's marking where this is coming from. Don't just come up with some sine theta we don't know. Okay, it's ridiculous. These 3 marks are not given, so we need to be appreciative of things. So we know that A, B, D is equal to theta. Now that was indicated as theta, so we don't know how to name it otherwise. So these are alternate angles with, okay, this time parallel lines don't really matter, I guess. Even the reason is not that significant at this stage, but we just know these are alternate angles. But usually alternate angles are only equal once these two lines are parallel. So we don't know where this line segment is going to. So we can just say these are alternate angles. In fact, to avoid troubles at this point when there's not enough info for us to make a sensible reason, we just leave it at that. This is going to be a mark on its own. Okay, so number one. Number two, we now know that then this spelling is spelling out cos. So we know that cos of theta is going to be adjacent, which is 64, divided by hypotenuse, which is 81. You can say therefore theta is going to be the arc cos of 64 divided by 81. All right, so therefore theta is going to be what we get. So arc cos 64 over 81. Now to the nearest, this is 38 degrees. Okay, not a big deal. So that's it. So we have our theta. Of course, this is important, the definition and the answer. Okay, nice. So 7.2. We are given that BAC, can you see? BAC is this angle. Can you see? 82.6 degrees. From the diagram, this looks acute. Oh, no. BAC, Lord have mercy on me. BAC is that angle. Okay, so that's the one. That is 82.6 degrees. Not a big deal. So this already says we can use the cosine rule to get BC, which is likely to be the question here. All right, so that's easy. So we're going to be working on this triangle. So this is the triangle that we're going to be using, the big one. Okay, so what are we saying there? We're going to say in triangle ABC. Okay, what do we say? We want BC. So we know that BC squared is going to be equal to AB squared plus AC squared minus 2 times AB times AC times the cos of BAC. This is the cosine rule. Okay, so this implies that BC squared is going to be AB, that's 81, squared plus AC, that's 87, squared minus 2 into 81 into 87 times cos of the angle 82.6 degrees. Therefore BC is, obviously we took a square root there. I'm not going to waste time. I'm just going to take square root of 81 squared plus 87 squared minus 2 into 81 into 87 into cos. Now here brackets are very important. Into cos 82.6 so the brackets need to be right, otherwise you get a math error. So no one told us how to round off the answer here, so we're going to do it to 2 decimal places. So this is 110, 9, 7 meters. Remember that distances here were in meters, so answer must be in meters. So very easy, again, standard textbook questions here. Writing the rule specific to the triangle, the substitution, and the answer. Do not forget the unit. If it is not there, there is no mark for the last answer, for the answer. Okay, 7.3. We are told that BDC is 110 degrees. So this is the 110 degrees, okay, which is what we knew we would not be able to deal with if we didn't have. We need to calculate the size of DCB. So the question is on this angle. Okay. Now, what do we have? We've got this angle, the opposite side. We've got this angle, the opposite side. We worked it out. It's 110.97 meters. All right, so we can use the sine rule in that triangle. In triangle BDC. So what do we have? We know that we're interested in the angle, so we can say sine of this angle DCB over the side opposite it, which is BD. At this point, I'm not interested in wasting time, so I'm just going to write, it's 3 marks. The rule needs to come up first. So over BD is equal to the sine of what is this? It's BDC over the side opposite that, which is BC. Okay. Now, this is the sine rule. Great. Then we substitute. We've got sine of DCB, which is what we want, divided by 64 will be equal to sine of 110 degrees divided by 110.97. All right, so therefore with cross multiplication, of course, you don't need to show the cross multiplication, but that's what you do. So we know that literally, for me, the one that we cross multiply here is that one. So we know that sine DCB is going to be 64 times sine 110 degrees over 110.97. Okay, maybe that's an implication rather than a conclusion. We can say, therefore, DCB is going to be the arc sine of 64 sine 110 degrees divided by 110.97. Phew. That's a bit of work, isn't it? Yes. Oops. Shift sine of 64 into sine 110. Now again, guys, brackets are a key into this business, otherwise it can hurt if this is not done properly. So nobody told us how to round off, so we're going to follow the general instruction. This is 32.82 degrees. Remember, guys, the rounding off here is key for it to follow the general instruction, because there was no specification as to how many decimals are we accepting. So easy again, standard textbook question. These were easy marks. I don't know why these guys failed this. They should have passed big time. Anyway, writing the rules specific to this triangle, and then substitutions, and then the final answer. That's very easy, 9 marks of this question. If no mistakes have occurred. But sometimes they always find their way into our work. Now comes the naughty boys. The naughty boys, Euclidean geometry. Let's just quickly get through it. Of course, guys, I'm not going to do the proofs. Are there any? Okay, there's just one, the similarity one. Okay, not a big deal. But the proofs are textbook matters that I don't really have interest in at this stage. So let's go on. Euclidean geometry needs us to be awake, guys. So for me, I would rather as a student you start with Euclidean geometry when you're doing paper 2, okay? Follow with trigonometry because those 2 sections can be exhausting. There's a lot of work there, but you, if you've been following my channel and all my rants, you should find trigonometry as a piece of cake. It's not really difficult. In my opinion, is one of the sections that has a lot of marks for a student to pick up. So I would say, if you start with Euclidean geometry while your brain is fresh, you can get as many marks as you can because that thing can be horrible. Obviously, most of you do it when you are tired, and that's the mistake many of you do. Start with Euclidean, maybe do trigonometry because it's quite a long section. There's a lot of marks because of its length, not difficulty. Well, there can be challenges, but usually it's just too long. Get that done while you still have time. You're not in a hurry. You're still in the mood to check things. Then analytical geometry, of course, because it applies the 2 sections and algebra and functions and whatever. Take down those questions. Now, this is where marks also can be scored. Of course, guys, if you fare well, you'd rather do statistics in a hurry rather than to start with statistics and suffer at the end where the big marks are. Stats, as the last question, is easy because even if you lose the last mark, there is usually 1 mark or 2 marks. It's nothing big. Euclidean geometry can punish you if you get to it tired and out of time. Anyway, let's do it. In the diagram below, P, M, T, and R are points on a circle. So what do we call these points? They are, what do we call it? What do we call points that lie on the circle? And can you see there are 4, so they form a cyclic quad. So what do we call these? They are concyclic points, meaning they are in the same circumference. And of course, whatever figure they make up is a quadrilateral that is cyclic because all 4 vertices are at circumference. Okay, guys, so please, 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 it is critical to know this. So basically, this is another way of saying MPRT or MTRP or PMTR is a cyclic quadrilateral. O is the center of the circle. So if O is the center, these are ready. Okay, they are equal. Nice and easy. Now we're told PR produced. So once a line is produced, it means it is a continuation of itself. All right, so it doesn't really look nice there. Okay, maybe let's rather extend it a different way. Okay, so that is better. So once this is produced, it means we have a straight line. And now what does this mean? Well, it creates an exterior angle of this cyclic quad. So it should be equal to that angle as a whole. Okay, great. So that's us working with every piece of information given to us, because not doing so is detrimental. Of course, this meets MS. This is to suggest this is a straight line. MS at S. Okay, not a problem. Now, ready, OM and OR and chords MT and TR are drawn. Okay, great. T1 is 148 degrees, where PMO is 18 degrees, and S is 43 degrees. So all of these are indicated. We can just move on nicely. So obviously, having discovered what we have, we are happy because opposite angles of a cyclic quad are supplementary. So we can use that piece nicely, and we can see this O1 is an angle at center. So we can either use this and the reflex angle, then use the revolution to find O1, or we use T1 and P to get P first, then 2 times P is going to be O1. So everything is just going nicely there. So 8.1 with 8.1.1. Excuse for the noise, guys. I'm struggling a bit. Calculate with reasons the size of P. So we know that angle P plus angle T1, this is going to give us 180 degrees. Why? These are opposite angles of cyclic quad. Name it PMTR. Why? We know that because those vertices are at circumference, or those points are concyclic. So we go on and say this implies that angle P plus T1 is 148 degrees. Please guys, don't jump the steps just because it's convenient. Don't take advantage unless you are in a hurry. But I will tell you one thing in life: learn to give everything its attention in terms of detail, good execution, and ensure that at all times this is what you do. You will be the best of all people. Remember, when we're looking for jobs, guys, it's not about passing an exam. And looking for a job, sometimes you get given what you call probation. Because you can pass the interview but become a disaster. So this is why there's such things called probation. You will fail dismally by being haphazard and erratic, just chaotic. Now, that guy who was probably ignored may be called in for probation as well. And that guy may just pass the actual test, because for me, an interview, people can cram how to answer and behave. But when you put them on the field, you start to see who is who. Okay? Irrespective of what they are feeling. This is why when you become a useful individual, a graduate, although many graduates are just graduates for the name of graduating, but they don't really represent what they actually graduating from, because they can't do anything with it, which is sad, because it shouldn't be that way. But again, the reason it is that way, because people just study to pass, which is fine. You don't want to waste your money at university by repeating modules or what. But if it happens, it happens. What are you going to do? We all sometimes suffer despite our intellectual abilities. There are lots of reasons for us to suffer. Some of them It's just nature itself humbling the individual for a reason, to make you a better workforce in the near future. Because if you're arrogant and you think you know too much, you will be humbled by failure when it matters the most, and that's when you're going to lose out big time. But yeah, essentially, those who are lucky when they are cocky like myself, they get punished by some crazy failures, which I also did experience along the way. But the most important thing is those failures came when it wasn't really a matter of survival and death. So my failures would come in between, like the tests, which of course are very important because they speak a lot in terms of your final mark to decide whether you are gaining entry into the final exam or not. But at least I failed tests that did not compromise my chances of sitting for the finals. And I never failed a final exam, thankfully. But it's only because I was always prepared for it long before it comes, because I read for meaning and understanding. And when the need arose, I then tried to survive an exam, but I immediately made sure I review or at least go through the sections I may have not gone through adequately on my spare time, because I hated the idea of not meeting the requirements of the goals by the course coordinators or designers, or whatever you call them. Remember, for every course you get at university, there's always that little booklet that tells you the objectives of this course, what a student or at least a candidate must be able to do or must be, in the knowledge of by the end of the course. I made sure those objectives have ticked, all of them. And beyond, I would challenge myself by going the extra mile, because doing so ensures that there's no exam you will ever fail. You may not excel, because when you have knowledge, how you answer sometimes puts certain people off. Sometimes you miss the point because you overly analyze. You're not just regurgitant. And many people who are simplistic in approach, which is usually the case at universities, they just want the answers that they know. They wouldn't really have time to read. Remember, in my class, we were 200 when we started, 200 some change. Imagine you have to deal with scripts of 200 students. Yeah, think about it. And you have to publish these marks within a week. Yeah, sometimes it gets a bit naughty. So I understand that it's not easy, but this is why you need teamwork. That means your work must not only be known by you, even your colleagues, because you need to be able to take those scripts to your colleagues. And you must have a team of people who resonate with how you do things, so that they don't compromise your students, especially if you are the examiner. So anyway, guys, hey, let's not talk. Sometimes it's timeless that makes me do this. Let's start. I know many of you are going to just rush. Angle P is equal to 32 degrees, opposite angles of a cyclic quad. Nonsense. I would mark you down for that, because it tells me you copied. Remember, guys, an exam is another thing people take for granted. An exam is not, just going through the motions. An exam is for you to show that you know and that you did it by yourself. There has to be proof in your answering that tells someone that you are the one who's doing what you are doing. It's not somebody else. The moment you come with some shorthand answers here, where we can place some questions, because you can't, for example, get that question 1 right and then you fluff the next 2, and you are doing this by yourself and you came up with a shorthand answer. That's already saying bad things about you. And now this is how most of you fail. You go into an exam and you're excited, at least I got this question, and you wonder why your marks are so low. You actually lost that mark because you gave the indication that you are copying. Because how could you do that in a shorthand manner that says you understand this thing, and then you come and fail the others that pretty much are of the same level? That's ridiculous, isn't it? It can take a mistake to do that. And again, a mistake would only affect perhaps one question, not all. So be very careful, guys, of your behavior in the exam. You will cry. Now we want O1. Nice. So we know that angle O1 is 2 times angle P. This is angle at center equals 2 times angle at circumference. Great. So this implies that O1 is going to be 2 times 32 degrees. Therefore, angle O1 is 64 degrees. Guys, be systematic. Do not be haphazard. Show that you are doing this ngokwakho awukopanga. Okanye kukho mntu ukukopisileyo. Ngoba uke waqala waxakeka yile mibuzo ilandelayo. Ibe yona ikwizinga elifanayo nalo ungentla uphendule ngendlela esingathi isulungekile. Indixelela loo nto uba uyakopa wena. Qha qaba. Ndiyakulimaza nakulaa question ingentla ngoku uyifumene. Ngoba uyifumene kanjani ugqiba ungazifumani ezezinye? Uxakeke ngokupheleleyo. Udideke udidizele ube sowuba dizi. Hayi. Mayingabi njalo. Cannot be like that. If you missed what I just said. Yeah, sometimes to translate is crazy, isn't it? It's exactly what I said in English before I said it. Okay, you can't struggle. You can't get this question right and then struggle to get this one right. There's no way. Okay? If you do, then it means you copied the first one. So you go down for both if I am the person who's marking, because there's no proof in your answering that says you did this by yourself. So I'm not just marking what is right. If it is questionably right, it goes down by the head. Of course, maybe for review. Because it's not that easy that you just fail somebody, right? But you flag it for review. And an investigation. And, the conclusion of the investigation. This is when your marks get held up while others are out. Hey, guys. Yeah. Masingathethi kakhulu. 8.1.3. We need OMS. 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 So how do we find OMS? It's just 2 marks. Now, if it is just 2 marks, what does this mean? It means we need to have eyes of an eagle. OMS. Can you see? It's part of this triangle. Okay, this one is not doing great. Maybe let's just make it out. You see this big triangle? Yes, that one. OMS is basically this 18 degrees plus. Sorry, OMS is going to be OMS plus that 18 degrees. Right. And if that's the case, remember we already know P is 32 degrees. We've got it. So, now we have 3 angles of a triangle. This is 43. This is OMS plus that 18 degrees. So this helps us to find this. Because if you look at the mark allocation, it shows that this is very simple. So we can try to show where we are in triangle. Say PMS. All right, so what do we know? We know that angle P plus, let's say PMS. Let's not write PMS. I'm tired of this. we can bunch these and say this is going to be OMS, which is what we want, plus, let's say PMO, plus angle S is 180 degrees. This is the sum of 3 angles of a triangle. Now this implies P is 32 degrees plus OMS, which is what we want, plus PMO, which is 18 degrees, plus 43 degrees, equals 180 degrees. Therefore, angle OMS is going to be, now let's see, 180 minus the sum of these, 32 plus 18, plus 43. So this is 87 degrees. So this shows, indeed, if we look at that angle, this OMS is this angle. So that angle, it's definitely an acute angle of this range. So it should make sense, not necessarily drawn to scale, but it should not be too far off. So how many marks there? 2 marks. Okay, maybe substitution and answer. This is a very weak one, but again, it may be marked instead of the substitution. It's not a big deal after all. So this can also be marked because reasons are a key instruction here. 8.1.4. Now we need to work out R3. So where is R3? This is this guy right here. Okay. Now R3, we can clearly see this is the exterior angle of this situation. Of course, someone is already telling us that TMS is 6 degrees. Okay, not a big deal. So this one is 6 degrees. Okay, not a big deal. Now, what is the purpose of doing this? Is to say, well, the importance of this TMS is to try and this is to try and to say, look, in this angle PMT, because we need that whole angle PMT. Now, if we look at OMS, if we say OMS minus the 6 degrees, we get OMT. And OMT plus the 18 degrees gives us R3. So this is the essence of this question. Of course, this one is a bit tricky because the 2 marks is not representative of the amount of work that needs to be done. So it's hiding the fact that it's a bit naughty. So anyway, we will start by saying R3 is going to be equal to, essentially, now let's see, what is the story here? It's going to be OMT plus PMO, as we have stated above. Right, why is this? This is the exterior angle of a cyclic quad. What was that? We said PMTR. Okay, so this implies that R3 is going to be OMT. OMT is essentially OMS minus TMS. So OMS, we got it as 87 degrees minus this 6 degrees plus PMO, which is 18 degrees. Therefore, R3 is the answer. So we've got 87 minus 6, it's 81, plus 18. So it gives us 99 degrees. Yeah, it looks, yeah, but it doesn't look like it, eh? Hi, turning at is a curtain go OMT is OMS minus 6 degrees, but I think that 6 degrees is not fair because now this is saying this is 100 degrees. Hell no. This is still very much less than 90 degrees. It's not an obtuse angle. So this is where I'm not happy with these questions, but yeah, I haven't done anything wrong as far as I'm concerned. So yeah, as far as I'm concerned, PMT is made up of this PMO plus OMT as we have, and OMT is basically OMS minus 6 degrees. So yeah, but this is so wrong. It's not right. It's not right. Did I calculate my OMS correctly? So let's say 180 minus the sum of 32 plus 43 plus 18. Yeah, it's 87. Then when we subtract 6, it gives us 81, which is fine. It's not too bad. But 81 plus 18 makes me uncomfortable. It's 99 degrees. Anyway, guys, this is by no means an obtuse angle by the look of it, but this is, I think this 6 degrees is random. It's because of the random. Sometimes I don't like examiners for this. Guys, we need to try, even when we pick some random answer here. We still need to make sure that the diagram, although not drawn to scale, but has to be representative of this answer. We cannot have an acute angle and on a calculation we have an obtuse angle, because it makes students to question that answer, and as a result they waste time trying to make sense of this situation, trying to see if they have not made mistakes. So the exam must not be by design faulty to lead a student away from the right path. Because that's not fair. That's like tricking the student to a fail. And yet tricking a student must not lead to the student failing. The student must fail themselves. A trick is just to check how proficient they are, not to mislead them into a failure. Okay, that's not right. It's like the devil now. The examiner is being the devil here. The devil will show you some nice things that are actually going to kill you and turn you away from things that look bad, but they're going to make you better. So, anyway, guys, whatever. Sometimes it is as it is. So that's it. So, sorry, guys. I don't know why I'm coughing now. This is powerful. For me, this is also powerful because it's a calculation on its own. That should be 3 marks. So whatever these guys are smoking, it's certainly something else, not in Tsango. Sebebhemi heroin labayana sesiyababona. Bakwazi ukuthi i2 marks lanto. Noko bayahlanya. Sorry. That's craziness. Okay, leave it as crazy as it looks. And the diagram below, the circle passes through A, B, and E. Again, what does that mean? It means A, B, and E are concyclic, but this makes it a triangle. So you can call it a cyclic triangle, because it is indeed. Usually a cyclic triangle will have something to do with the 10-chord theorem, isn't it? Yes. So always think about it that way, that there has to be a tangent somewhere. Now, ABCD is a parallelogram. Oh, nice. So a parallelogram, first of all, this means that side must also be equal to that side, because opposite sides of a parallelogram are equal. That means AB is equal to DC, and that is also equal to that. That's a strange situation. And of course, that side must also be equal to this side. That's parallelograms for us. So if this angle is what it is, so it also means that angle should also be the same. Okay? Because opposite angles of a parallelogram are equal. Okay. But this angle must also be equal to that angle. Seeing this notation right there. Okay. Those are angles opposite equal sides, or we can say angles subtended by equal chords, because we have a circle now. All right, so if this angle is what it is, it should also be equal to that angle. Okay, because these lines are parallel, so those are alternate angles. So basically, BE bisects angle AEC or CEA. All right. Carcinoembryonic antigen. Uzovumoy. Now, if this is a tangent, this angle will also be equal to that, right? But we don't know this, but perhaps it is so. BC is a tangent to the circle at B. Indeed, we have it now. Okay, so again, now guess what this does? This changes the signature here. The signature is that of the same angles. Why? Remember that angle and this angle with these two lines parallel, those are corresponding angles. So this also changes. So, yep, that is the story now. Asiseninzi izinto ezilinganayo hayi zingixakile. AE is equal to AB, down C1 is X. Great, so everything is X that we see. Now it says give a reason why B1 is equal to X. Where is B1? There. So these are corresponding angles. Okay, so we have 8.2.1. Corresponding angles with AB parallel to DC. Remember, the parallelity has to come in once we speak of corresponding angles. If this is not there, just corresponding angles alone, they are not necessarily equal. So you lose a mark for that. So you say corresponding angles provided you include the set of parallel lines to suggest that they are equal. Okay, now name with reasons 3 other angles equal to the size of X. Well, we've got this one, we've got that one, right? So this is also, that is also, that is also, right? Right. Aye, ininzi lento. But how did I end up with X? You cannot lie, Mr. Sir. No. Oh yeah, I ask in fits. Because this is equal to that. That is equal to that. 10 chord. This is equal to that. You know, this is an isosceles. And then this is equal to that. Opposite angles of a parallelogram. So, yeah. I did not lie. So we're going to say, well, we understand that angle BAD is equal to angle C1, which is equal to x. These are the opposite angles of a palm. Okay, we were given the parallelogram. So opposite angles in a parallelogram are equal. Yeah. Also, what do we know? We know that E2 is equal to B1, so equal to x. That is the tan-chord theorem. Okay, nice. So siyabangena. So city also we wanted 3, right? 3 other angles. In fact, we have more than that. So how do we name this others? Of course, this must get there before we get here, isn't it? Yes, of course. Yes, of course. So we can say, okay. Masiyeke le conversation. Let's just list them. So we say B2 is equal to E2 equal to x. Now these are angles subtended by equal chords. We name them. AB is equal to AE. Of course, can easily say angles opposite equal sides in that triangle, but angles subtended by equal chords is much better since we have a circle. Okay, we've got these ones. So statement, reason, statement, reason. So we get those 6 marks. Easy 6 marks otherwise. Okay, here we get 1 mark, provided everything is good. 8.2.3. So we need to prove that ABED is a cyclic quadrilateral. We know that this is equal to that. They're alternate angles. Therefore, this is equal to that. So the exterior angle is fulfilled. Okay. So what are we going to say? We will say, well, we understand that E3 is equal to B2 equal to x. Why? These are alternate angles with AB parallel to DC. Good. But now what does this mean? We also proved that BAD was x. So we can say therefore, or perhaps this implies that E3 is equal to BAD. Right. This is because each is equal to x. Because we saw that above. BAD was x. Now if E3 is also x, then this means these two are equal. Now if these are equal, this fulfills the exterior angle of a cyclic quad. So we can say therefore ABED is a cyclic quadrilateral. This is the converse of the exterior angle of a cyclic quad. Okay. Now the key is that this is the converse, because ideally we get told this is a cyclic quad such that the exterior becomes equal to the opposite interior. Now if we prove the angles that the exterior is equal to the opposite interior, it conversely means there is a circle around those points. So that's it. Easy. Again, this is grade 11 standard grade material. Nothing higher grade here. So this paper has been very standard in nature. So my student, why did you ask me to do this question paper? It's too standard, man. But anyway, there's learning points, as you can see. Sometimes it looks standard to me because I know what to do. It may not for the student who's still trying to figure things out. Or perhaps my student is just smart, which I know they are all smart, but they want to see an opinion of me on certain issues. Perhaps there are some areas in this paper where maybe their confidence in what they see is not so good. As you can see, this one in particular, this one, okay, the head was not fitting tightly, so maybe that's where the point was for my student here, that hey, what's your comment about this paper? Was it good? Was it bad? Where were the bads? Where were the goods? All right, there you have it, my student. I hope you have enjoyed it. Statement and reason, important. Statement and reason, maybe 2 marks. This is a weak one, but it can be considered because those two have to be equal for us to say what we have to say at the end. Otherwise, this would have been an easy 18-mark grab and forced into the bag. The bag is getting thicker and bigger. Okay, guys. Now, let's get to question 9 on a new page. Okay, question 9 says, complete the statement so that it is true. The angle between the tangent to a circle and the chord drawn from the point of contact is equal to the angle in the alternate segment. Now, the wording of theorems is important, guys, to know well. Sometimes the 10-chord theorem is good, but yeah, this needs to come out. If not, you lose a mark. So I'm just doing it here. 8.2 says, in the diagram below, 2 unequal circles intersect at A and B. AB is produced, meaning it makes a straight line, to C. So where is AB? AB is produced to C, so this means we have a straight line there, such that CD is a tangent to the circle at circle ABD. So CD is a tangent, so I like to highlight my tangents. Oh, yeah, doch. Almost didn't come out nicely, but it's not bad. So if this is a tangent to the circle ABD, as indicated at D, the 10-chord theorem that we just stated is coming in. Usually, there would be a proof for 10-chord theorem before we apply it, but sometimes the wording can come in, and then we need to apply. All right, F and G are points on the smaller circle such that CGF and BDF are DBF are straight lines, okay? DBF and then CGF, okay? These are all straight lines, okay? Great. Very important piece to note. AD and AG are drawn again, same concolos, same WhatsApp group. So those refer to straight lines, not to the curves. unless otherwise stated. If then we are talking about an arc, we will say arc AD. If we don't say arc AD, we mean the straight line AD. Okay. Remember that. Alright guys, it's 4 a.m. here, man. Icon. I should be sleeping, but I'm not even feeling sleepy. How strange. Too much excitement. I don't know why my videos for paper 2 take long. Hey, I talk too much, but I didn't talk too much this time. It's very strange that I'm finding myself in this position. Anyway, leave that. What can we do with the information we are given? Hey guys, there's not a lot. All we have is the 10 chord theorem. Wow. Nothing else. Hayibo, yawena. I cannot believe this. I really cannot believe it. Yo, hehe. There's nothing much, guys. I'm only getting those 2 angles. I don't see anything else I can do here. There's nothing. There is nothing extra being said. Oh, there's more. There's more. I was about to cry. We can see that this angle on the smaller circle must be equal to that angle. Still on the smaller circle. These are angles in the same segment, subtended by chord AF on the smaller circle. Likewise, we will have A2, not A2, A2 equal to this angle F, right? Right, because these are angles in the same segment subtended by arc BG on the smaller circle. Okay, now there's a bit. There is a bit. In fact, that's all we can say so far. Yeah, there's nothing much. There is nothing much. Okay, nice. Okay, now we can start. 9.2. 9.2.1. We need to prove that B4 is equal to D1 plus D2. Okay. What is B4? So what we notice is that B4 is the exterior angle of this triangle right here. Okay, the one that we outlined purple. So it would be A1 plus D2, but guess what? A1 is as good as D1, 10 chord theorem, and that's how this is the case. Okay, all right, so great. Let's mark it differently instead of marking it in a way that causes us problems. So that is the angle, it's exterior for that triangle. So we can say in triangle ABD, what can we say? We know that B4 is going to be equal to angle A1 plus angle D2. This is the exterior angle of a triangle, ABD. Alright, we've got a story, but we understand that D1, or maybe let's say A1, is equal to D1. This is the 10 chord theorem. Okay, therefore B4 is going to be equal to D1 plus D2. Is finished, right? Right, statement, reason. No. Here, Statement and reason. Damn. No man. Okay, statement and reason, statement and reason. The substitution was already given, so easy. Okay, this one was a very easy question. I don't know why 4 marks. Anyway, 9.2.2. As I said, guys, it may be easy to me because I know what to do, but it may not be so easy for the student who doesn't know what to do. A, G, C, D. A, G, C, D. We need to prove that this is a cyclic quad, okay? Okay, so that is the cyclic quad that we need to prove, okay? So obviously, guys, I'm doing these shadings just for demonstration purposes so that the student can see clearly. But by the time a student is supposed to be sitting for the exams, the student needs to be able to see these things without shading and stuff, okay? The shading is to assist for practice and to follow what I'm doing, because the one thing I would not like to do is to repeat myself, okay, over what is supposedly obvious. But in the exam, we need to be able to see this without doing the shading, okay? That's very important. But again, doing colors is very nice because it helps to separate things. Now, how do we prove that this is a cyclic quad? Well, there are 2 ways we can do that. We understand that, hey, hold it. U are vertically opposite the U. So the story changes now. So those are equal, but this is equal to that. Again, angles in the same segment subtended by chord AF. Now technically, this angle right here is equal to this angle, which is equal to those two together. Holy cannoli. Now this is the story now that is exterior angle of a cyclic quad is kicking the dust. Okay, great. So we have it. Now, number 1, we are going to say, hey, look at this. We know that B2 is equal to B4. Essentially going to be equal to D1 plus D2. Why? These are vertically opposite angles. They are always equal. Okay, that's number 1. We'll say, however, we know that G2 is equal to B2 and essentially going to be equal to D1 plus D2. Why is that? These are angles in the same segment. All right, okay, we can keep it as short, but we know that they are subtended by chord or arc AF in the smaller circle. So what this makes, it proves for you and I that basically angle D1 plus D2. Okay, but I think this is already good because these two link by that. So yeah, this is already done. So what can we say? We can say therefore AGCD is a cyclic quad. Why? Remember, we proved the exterior angle is equal to the opposite interior, so this is the converse of exterior angle of a cyclic quad. Key is that this is a converse, right? Right. Or someone may just say angles. So the exterior angle is equal to the opposite interior angle. But I think the best way is to say converse of exterior angle of a cyclic quad because we proved it there. Right. Right. So that's how we cruise over there. Easy 4 marks again. Here, the statement and reason. The reason is more important. Perhaps statement and reason there. That's a bit fair. Okay. That's a bit fair. So let's see 9.2.3. This says we need to prove that DC is equal to CF, that one. Okay, so this means we need to look at this triangle DCF, and we need to prove that this angle F is equal to that angle D. And if that can be the case, then this would be an isosceles triangle. Then the conclusion would be that. So let's see, how are we going to do that? Well, first of all, we know that this D1 is equal to A1. But then A1 stops the nonsense. Then we've got A2, which is equal to this F. Angles in the same segment subtended by arc BC in the smaller circle. But this one is not equal to that, because even though we proved this is a cyclic quad, but do you see that this arc does not subtend that angle as much as it does subtend A2. So these ones don't make the angles in the same segment in the cyclic quad work, unless we were told, which we haven't been told, that ADCF is a cyclic quad. Because if that was the case, we could easily say A1 is equal to this angle, while that A1 is equal to D1, therefore this angle is equal to that. So there's missing information here. I cannot answer this question unless there's a different approach that the students have, because I don't see. I mean, we can try some elimination techniques, which are not going to get us anywhere, to be honest, because I don't think they will. Because I mean, even if we look at this small triangle and say this angle plus that corner angle up there is going to give us G1. That's the exterior angle, right? Right. So, but now we have an angle that we don't really want as much as we have this one. Now, we also know that this angle plus that angle, those are, okay, let's try and see, but I don't think it's going to work. Now, folks, focus on this triangle. Focus on this triangle. See the small one here? I'm going to focus on this triangle. I'm just trying, but I don't see this working for 4 marks. Well, we know that G1 is going to be equal to that angle F plus this other angle, which I don't know. Maybe let's call it an asterisk. Yeah, doch. That angle, we have an asterisk there. Okay. So that's an exterior angle of this triangle, right? Right. Now, what do I know also? I also know that this angle asterisk is still the angle asterisk there. Those are vertically opposite angles, okay? Leave that for now. Make this one equation 1, okay? But now we also understand that, I don't know if it's going to work, guys, but it may not work. I'm not sure. But let's see. We know that G1 plus those two, D1 plus D2, must give us 180 degrees, right? These are opposite angles of a cyclic quad. Okay, let's not write the reasons now. We just want to see if it works. So that would be opposite angles of a cyclic quad, because we just proved this is a cyclic quad, the shaded part. So what are we trying to do? We're trying to use G1 as some scapegoat of some sort. Okay, I'm thinking, do I really want G1 out or what? Okay, let's see. Yeah. Maybe G1 needs to go. So in this equation, we're going to say G1 is essentially F plus the asterisk angle plus D1 plus D2 equal to 180 degrees. So what I've just done, I took G1 and substituted there. Okay, that's something. Now the question is, this guy is a foreigner. Can we get rid of this dude by any chance? Maybe we can. Let's have a look. If we look at this triangle now, that triangle AB, whatever this is, we can actually work out this angle in terms of B2 and A2, right? So we know that this is going to be angle F plus this one. From three angles of a triangle, this is going to be as good as 180 degrees minus the sum of B2 plus A2. Right. So this is just standing for the asterisk, and then we still add D1 plus D2 equals 180 degrees. Okay. Now, we will see that 180 takes care of 180 because they're the same sign. And then we distribute the negative F plus, this is minus B2 minus A2 plus D1 plus D2 equal to 0. Now, what do we know about B2? B2 is D1 plus D2. Okay. Doesn't look like it's going to work. So B2 minus B2 and yeah, it doesn't work, guys. It fails because B2 actually is as good as these angles together. So these ones will eliminate as well. So it just shows that F is equal to A2, which is already what we know. F is A2 angles in the same segment. So yeah, it fails. Okay, I don't want to waste too much time, but sometimes you can try simultaneous equations. Try and see if you cannot get it. But even looking at this angle here, I'm not convinced this angle would be equal to that. Again, it's not drawn to scale, so there's not much to read out of that. But it almost looks like we would be getting somewhere because all we wanted was to prove that F is D1. So now I'm trying to think. Could we change D2? But we can't. We can't. If everything eliminates and leaves us what we already know, so it's not working. I think here, I'm not sure, but you guys can check the memo if you find it. What I can tell you is, essay exam papers usually has paper 1 and paper 2 and its memo. So you can check there. But my feeling is that if this fails and it looked like it's going to work, maybe the mistake has been made by the examiners here. because it is with the assumption that F is equal to A1, and that would connect there. But remember, we were not told that ADCF is a cyclic quad, so we're missing that. Perhaps there's a statement that was cut here, I don't know, but that suggests as much in my opinion. But let's leave it at this point. I cannot solve this last one. So for me, it looks like there must have been a link between F and A1, but then we needed a statement that says this is a cyclic quad, and we don't have such a statement. So as a result, we cannot comment further. Okay, so questionable this one. All right, guys, the similarity, I've shown you Euclidean geometry for grade 12. I'm not gonna do that. It's easy. All you have to do is to take this triangle into this by construction. Of course, we can say MVT is MN O, if we like, such that this is equal to that, that is equal to that. All right, and the angle is already like that. So, but my construction looks crazy. Okay, it doesn't. So, essentially, what we need to prove now is to prove congruency of this triangle and this triangle. From there, we will prove that this angle is equal to that angle, equal to that angle. Okay, maybe let's make it look different. All right, so if that's the case, it will conclude that this line is parallel to this line. All right. Once we prove parallelity, then proportionality theorem kicks in. Sorry. The proportionality theorem kicks in. Okay. And that's how we prove this thing. So there's no need to fail this. It's very easy. Okay, let's just get to its application, because I think that's what matters the most. So how did I get to question 10 anyway? Oh, I skipped the proof. Okay. So we're going to do 10.2. Now in the diagram below, cyclic quadrilateral EFGH, it's already clear, is drawn. Chord EH produced, EH is produced, meaning straight line, and chord FG produced, again they meet at K, so these are straight lines. M is a point on EF such that this is the case. Okay, good. Now also KG is equal to KG is equal to EF. So if KG is equal to EF, this is interesting now. We need to pay attention to that. This means we can substitute GK or KG for EF or vice versa. So that introduces that. And it means somewhere in these ones, you see, either that or that is going to have that substitution once we do our business then of one by the other. So that's just the key. Otherwise, again, these questions look fairly standard to me. All right, 10.2, 10.2.1. We need to prove that triangle KGH is similar to triangle triangle KEF. Okay, let's see, where are they? So basically, guys, those are the two triangles that we need to prove similar. So this is easy. In triangle KGH then triangle KEF. Okay, so KEF is the big one, the pink outlined one, and KGH is the shaded one. Okay, that's easy. First and foremost, we see that they have a common angle, K. So you can just say angle K is common. Right, number 2, we can see that this is a cyclic quad, so this angle should be equal to that angle. So this is an exterior angle of a cyclic quad. So we can say safely G3 is equal to angle E on the big one. Now, what is this? This is the exterior angle of a cyclic quad. At least we were told that that is a cyclic quad, so we don't need to state it. That's the only quadrilateral that is the only cyclic quad we have so far. Now, once we prove 2 sets, it's already done, guys. The third angle was always there. But let's do it for completeness sake, because I see in your exams the proofs go beyond this. But with us, if you prove 2, that's it. The third one falls into place. We can just say this implies that H2 is going to be equal to F. Actually, that's also the exterior angle of a cyclic quad. But we can just say the remaining angles, or the third angle, or sum of 3 angles of a triangle. So therefore, we appreciate that KGH is definitely similar to, not KGH, but triangle, to KEF. This is AAA. Alright, they are equiangular. So easy 4 marks here. Of course, this is a very good one. This is a very good one. So we can mark everything. Okay, not a big deal. So 10.2.2. We need to prove that EF squared is equal to KE plus GH. Now, what I often do with these questions, because usually these can be crazy, always check, where is EF? EF is part of the big triangle. KE is part of the big triangle. GH is part of the small triangle. So of course this looks like we did something there. So let's try and work this out. But since GK is equal to EF, it means when we have GK, we will substitute it with EF to give us the EF squared. So can you see, this is where this business came to rescue us. So if you inspect what is given in terms of what you have, you will always know what to do. So what do we know, guys? We understand that, hey, EF over, now EF is the big one, is opposite this angle. And what is the side opposite this angle in the smaller one? Is GH. So over GH is equal to, we know that KE belongs there, so this is easy, it's leading us. KE is opposite F. F is equal to H2. Side opposite that is GK, or KG. How it was put, KG, yes. Now these are the proportional sides of similar triangles in 10.2.1. Please state this. Okay, I don't know why this is dying on me. In 10.2.1. Because once those triangles are similar, we know that the sides opposite the equal angles are going to make up. proportions of equal value or equivalent fractions. You get it. So we cross multiply here. We don't need to show this, obviously. So this implies that EF times KG is equal to KE times GH. Okay, we've got a story here, but we know that KG is equal to EF. So this implies, okay, this was given. So this implies that EF times EF is going to be KE times GH. Therefore, EF squared is equal to KE times GH. Although this is 2 marks, folks, which for me is ridiculous, it's hiding the fact that there is a bit of work to be done here, because first of all, constructing this is a mark on its own. Okay, with the reason. The cross multiplication is not a big deal, but I guess the substitution is what matters here. The rest is history, okay? So not a big deal. As much as it is 2 marks, there are some areas that need to come out, and that's where it matters the most. Basically, this mark is for the substitution. So can you see? Algebraic ways are still part and parcel of our life, even when we get to Euclidean geometry. Oh, guys, time is flying. We need to prove that KG, where is KG? KG is this side, but now this is squared, okay? Is equal to EM. EM is just a portion there. So, holy cross, where does this EM come from? Okay, not a big deal, we will find out. And then times KF. Okay, so this, oh my lord, we saw that this was parallel to this. So if we look at the big triangle, we've got the proportionality theorem here. Nice. And of course, for this KG to be squared, something is going to have to give somewhere. Okay? Of course, we know that FE is the same as KG. So as we did, this will keep on doing the things. Okay? Not a big deal. So let's look. We'll say in triangle KFE, we understand that we want KG to come up. So KG is nothing but FE, right? But either way, we don't care how we do this. Let's see, KF. Okay, let's start with KG. So we can say KG over, remember, this over the entire side, right? Because of this line parallel to that side, KG over KF should be equal to EM over EF. So it's going to be EM over EF. Now what is this? This is the proportionality theorem with MG parallel to EK in triangle, or in a triangle. Let's just leave it at that, in a triangle. In fact, I don't think we need to state in a triangle, because we already stated the triangle we are working with. So I don't know why I'm adding too much. Okay, that's good. So again, we do the cross multiplication. We don't need to indicate this. So we just go with the implication that KG times EF is going to be EM times KF. We'll say, but we know that kg, or maybe let's use the other one. We know that EF is equal to, oops, this looks like GF. We know that EF is equal to kg. It was given. We will then say this implies that kg times, instead of EF we write kg again, must be equal to EM times KF. Therefore, kg squared is going to be equal to EM times KF. Okay, these proofs, guys, are usually the harder ones to do, but again here, the examiners kept it to a very fair type of both higher grade and standard grade questions, because these ones would fit both standards of examinations. Anyway, so this is it, folks. Easy, 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 easy. So this statement and the reason, I think, is good. Then the substitution here is what matters to get those 3 marks. All right, so let's get to the last one. 10.2.2, it says if it is given that KE is 20 units and KF is 16 units and GH 4 units, we need the length of EM. Again, these are 3 marks. But now this will have to force us to find let me see. Yeah, it needs us to find first. Okay. Let me see what is going on here. This is so easy. Why 3 marks? EM. Oh, we need kg. But kg is the same as EF. So we need to first find EF. Then we substitute for kg. Then we are done. Okay. That's not a big deal. So what can we say here? Let's squeeze it. 10.2.2. We know that EF squared is equal to essentially KE is 20 times GH, which is 4. Say therefore EF is going to be the square root. 20 by 4, that's 80. Square root of 80, so we can just write it as square root of 80 units. Yeah, KE times GH, so that's 20 by 4, that's 80, and then say square root answer. It gives us 4 root 5. Okay, maybe let's write it that way. 4 root 5 units. We now know that then, okay, maybe we should have written this separately. We can say then we know that kg, in fact, I don't like to write this. Kg is the same as EF, so we have 4 root 5 squared is going to be equal to EM times KF, which is 16. Let's finish it up here. So this implies that EM is going to be equal to, this is as good as 80. It's going to be 80 divided by 16. Okay, so 80 divided by 16 is 5. So it's 5 units. Okay, good question right there. All right, okay, all right. If I was the examiner, I would probably bunch these two together into a 6-mark question. That would be a higher grade, because what is that? What is that? Oh yeah, it's just the department of what. Okay. Anyway, so that's it, guys. So this is for a total. I win, man. Stop doing this nonsense. Yes, son. This thing is wasting my energy. Hey, when. Heaven. I forgot that the extremes of things here are going to end up doing their own thing. So this is for 150, not 180. Okay, guys, I'm super tired. As you can see, this thing took longer than I actually wanted. So there is our question paper. Now it has shifted positions. Lord have mercy on me. Yikes, this sucks. Okay, guys, so again doing la question paper there, the memo here, man. Anyway, guys, so that's the review. I do hope you will enjoy it. And the question paper to be done. Oh, non-tokozo. Yes, I think it's non-tokozo. I hope that met your expectations and perhaps more in terms of the learning experience. Otherwise, guys, paper 2 is always the longest when you have to do this, especially if you're going to approach it like me, leaving no stone unturned to try and emphasize critical points for learning purposes, and essentially to not just rush through the solutions, because I can do it fast. Question is, will you follow? If you can, will you reproduce this in the exam? What will determine that possibility? So it's all dependent on the student to, do due diligence, study, read, learn, practice, and redo the whole process again. If you don't do it, you're not gonna win, believe me. I can show you all the question papers that are available on the internet, on DBE, examinations. I tell you, even if you were to watch them all, seeing me do it, you could still easily go and fail dismally, because that's me thinking, not you. And it's easy to see things when somebody else shows you. The hard part is to see these by yourself, for yourself. Okay, so we'll still do some work on Euclidean geometry, paper 2, grade 12 materials. In fact, let's meet at 7 tonight and handle that. I've got some nice questions from one of you guys, a student, which I think they're worth sharing with you guys in a lesson. So let's get to it and see how we can use our knowledge of similarity versus proportionality, or proportionality, in an advanced manner, so that you guys can appreciate the complexity that can come from this similarity versus proportionality thing, because these two are one and the same thing, but looked at separately, essentially. Otherwise, guys, I hope you liked the video. If you do, give it a thumbs up, share it with your friends. Perhaps consider subscribing into the channel for more. I can see now as more videos keep coming in, there's a tendency not to see most of the videos. You will only perhaps see the popular ones or the newer ones. But other videos are going to hide from you. So if you subscribed, at least you get to see everything. I hope that's how it works. But I may be wrong. I mean, I'm not a social media person. I'm not really caring how these things work. I'm just using them to, scratch the surface a bit in ensuring that some students who have the ability to do maths actually do not discourage, or they do not get discouraged by the challenge that the subject provides, but at least to offer them some support. Remember, this is just some support. The rest of the work needs to be done by the student, and I cannot lie to you guys and pretend my videos alone can make you the best. Yes, there is a chance for that depending on who you are. If you're already a good student who's getting, say, 60s to 70s, my videos alone can push you to a distinction standard. It would not be a negotiation whether you get it or not. You can get a distinction in every test you write with my channel. But I don't think I can convert someone who's hardly making it into someone who gets a distinction. No, it can only convert you from maybe a poorly performing or barely passing student to a passing student. Maybe getting the very best of which could be around late 50s, early 60s, but not more than that. Okay, so how do you convert yourself now from a barely passing student to a distinction candidate when using my channel? It means you need to read your books, as in your textbooks. Take those study guides that your parents bought you or that your friends suggest for you or borrow you. Read the knowledge in the book with an intention to understand it and to use it as a form of some second nature kind of thing. Because if you need a book again before you can see it and before you can apply it, then you are not doing any justice to yourself. You need to read, understand, practice, understand, review, double check, triple check, quadruple check. And once that is done, guys, what do you do next? You look at some past exam question papers, if you find them. Remember, they are not the only thing you can do. We hardly had past exam question papers, but we wrote our exams and we nailed those exams. So past exam question papers are somewhat an aid to those who are truly struggling, honestly speaking. Those who are not struggling, they don't really need too much of these past exam question papers. Unless, honestly, you want 100% and now you want to check every angle and corner. My question is, what does 100% do for you anyway? So why would you be fixating to this? National awards, perhaps? Of what use are they? Maybe there's something, but I don't see anything coming out, because those who become, anyway, let's not say too much, but for me, national awards should be a pathway to some very good scholarships for students, not just being named and given some lousy certificates. I also got those, but of what use were they? Because I didn't get a scholarship anyway, so they were useless. They're just sitting there at home, those things that, I was the best in physics, so what? Did I get anything out of it? Okay, maybe I'm too negative. I actually got to medical school. Okay, all right, that's fine. But if I didn't get that distinction, wasn't I going to get there? Back in the days, the competition wasn't too tight as it is right now. I probably would have made it. I don't know. I hope so. But yeah, guys, I feel like if South Africa is going to honor these students, there has to be scholarships for them to study whatever they want, wherever they want. In my opinion, we should be looking at the best institutions outside the country. You know, some of the prestigious universities like Cambridge in the UK or Oxford, you name them, USA, you know, MIT, you name them, Harvard, you know, Johns Hopkins, you know, those kinds of universities, because we want to train the best of our young people. We can't just, you know, have them dance here with everybody else and yet they have topped, you know, the performances in terms of achievements in the country. That's wrong, man. Buying a kid a car is a ridiculous thing, in my opinion. What are you doing to those people? What are they going to do with the car? That thing needs maintenance, it needs service, it needs petrol. Again, they need to know how to drive. Now already you're just giving materialistic rewards which don't enhance these kids' lives in a way. Even the ones you're trying to inspire, you're just giving them the wrong impression. That's why others are going to just go and rob those kids that car. You know what? Because they can drive it too. They may not drive it the normal way or the legal way, but they will still drive it. So anyway, guys, for me, please, South Africa, if you're going to award kids, you know, some certificates of best performances, those must be coupled with some scholarships. Maybe they do, I don't know, but at the moment, I mean, I keep hearing these kids being interviewed by some popular YouTubers in that they topped the classes and I mean the country in terms of the subjects. They got to their universities of their dreams, but I don't hear the part that says I got a scholarship because of this. But maybe that's what we miss, I don't know. But I also was one of the top achievers in 2005. I actually topped in physical science. But what the hell? I didn't get a scholarship. Maybe I'm bitter, ne? Maybe they're bitter. Ndiyakaka ndingukakayo ndiyintelezi. Maybe kunjalo, andazi. Hey bafethu. Kodwa ke mna shem, guys, to be honest, I guess I was just unlucky, or maybe God just had a different path for me. I'm just saying this in retrospect because at first I didn't understand, but now I then later understood. Look, there was the so-called East Rand Youth Trust. It had its head offices at the Emperor's Palace, okay? So essentially, I was part of the Star Schools program, okay? There was this Star Schools where they took the best teachers from districts and then they would go and combine in some college and get the best performing kids from those schools. So I was one of those guys because, I mean, maths and physics, I was unchallenged in my school. And I almost became a disaster even in that Star School because all the best in the district around me, they kind of, you know, suffered defeat, which is a sweeter thing if you think about it, but it's a bit cocky on my part because guess what? I'm not that special. But yeah, so then there was a possibility of getting a scholarship, technically a scholarship, guys. That was a good thing. And in fact, I qualified for it. But my problems came with the university selection. Look, the dude did not apply to all universities because I didn't care about UCT, you know, Pretoria, you know, KZN, Free State, WUSU, whatever. I was only fixated to Medunsa because that was at the time the most popular university in my, okay, let's not say the most popular, but for medical training, Medunsa happened to be the university that is mentioned a lot. So Medunsa was top of my list. technically. So I applied to Medunsa and Wits. Of course, Wits was one of the universities that I knew. But then I was kind of scared because I was like, yo, there I will meet with the beasts. I will just suffer there. So I didn't think I was fit for Wits personally. Medunsa was nice because it's in the township. So I knew that I'm not going to have an environment so different from where I stayed or lived. So in a way, I didn't like a situation that puts me in a compromised position, So I knew Medunsa was a safe haven for me in that I don't need to change my lifestyle at all. Nothing will pressure me to do so. I will just study. And the good thing was, it was one of the best producing university in terms of doctors and their quality as well. And the nice thing about it also that made it attractive for me was that there was no other subjects like law, not subjects but courses. So we knew that political activity is not going to be that much of a problem. I hated those things. So I hated it from the SRC, even at high school level. So I was one of the harsh members of the SRC because I was part of that, but yeah. We kind of did away with the bashes. That year, 2005, okay, bash eventually did happen, but yeah. Did it happen? I don't remember, but we kind of kicked it aside. I think it did not happen. We didn't want it. I didn't want it because I felt, no man, no. Matric dance was the best thing, I guess. The farewell is fine, but no bashes. Bad behavior must not be associated with school. Never. Because the music that is played there is a rubbish music. The dancing is also rubbish dancing, actually. So no. Anyway, guys, but what I'm saying is, guys, East Rand Youth Trust thing. So guys, my only problem, actually I was going to get that scholarship, 100%. But the challenge for me was that I only applied to Medunsa. And the adverts, they told me they had closed by the time I applied. Little did I know about this late application thing. So it looks like they considered me for the late application instead. I don't know. I think so. But then there are two things that may have happened with vets anyway. At some point, there was this Impala implants bursary. So I went for an interview in Rustenburg for that. So there, I mentioned that I wanted to study Bachelor of Science in Chemistry, right? At VETS. So they kind of captured that. Of course, we wrote this NBT there, because this NBT test was actually what we wrote there, we never wrote it, like you guys are doing it. But I think it was already there. VETS was already wanting it anyway. So as a result, they knew that if you wanted to go there, you must write that test. So we wrote that thing. And yeah, that's it. So only Medunsa now gave me a response with that student number or reference number at first, but it became a student number. So when I asked or inquired about the status of my application, they had not made the selection by the deadline that I was given at the Emperor's Palace by the East Rand Youth Trust. So they gave me a week to produce a letter of acceptance. Then they would give me the scholarship. Unfortunately, that very same deadline I was given, they told me that they would do the selection a week later. So unfortunately, guys, I wasn't given that scholarship. Oh man, that scholarship was good. That was good, man. They said they were going to pay tuition, accommodation, food, allowances. Then they would give you a pocket money to do other things like maybe, clothing yourself and stuff like that. So that thing was good, man. I missed out on something great. But I guess it would have made me too cocky, Because one thing I know about me is that when I'm not struggling financially, socially, or socioeconomically, I tend to become a beast of anything I do. But with some challenges in that regard, yeah, it became a bit of a stumbling block for me. It was more of a limiting factor. Because then I could not perform at the level that I wanted to because of those constraints. In a way that made me humbler, a little humble, because I was a bit an obnoxious individual, if you ask me. Too confident at best, and sometimes not paying attention to how that affects others around me. And I was ruthless, honestly speaking. I was ruthless. At least now I'm a bit considerate. So yeah, some challenges humbled me, and they made me perhaps a better version of myself than I would have been if I scored those scholarships and got to those big universities. And of course, I was never going to struggle. I was capable, very much capable by myself, for myself. So I would have been perhaps too difficult to work with for those who would eventually become my colleagues, because I am very strict. I'm sure you can pick up some streaks of strictness in my talks and my chatter. But yeah, 5 hours is over, guys, and I hope you enjoyed the video. And I didn't want it to be longer than 4 hours, to be honest, but yeah. You know, a review has to be a review. We cannot jump it and make it some kind of a race. You know, doing time attack. Then it defeats the purpose of being informative, showing the skills necessary to navigate certain questions, and exactly the background knowledge necessary to also navigate those questions. So for me, a complete review has to be something that is given time, because you will not have that much time in the exam, so you might as well use it while you have it, so that you can learn to economize better, knowing how to do it, because the knowledge would be there, flowing like milk in the land of Canaan, or Canaan. Is it Canaan? Is it Canaan? Canaan, yes. We imana phana nobisi kodwa abantu baphambane bathi hayi badikiwe ukutya into eyi-1 kodwa bayisebenzelanga abarubbish. Ningazodikwa ndim abantu thatha ixesha elininzi, kodwa ndim uthatha ixesha lam. Yayiqonda le nto, lixesha lam eli. Sanondixelela into yoba yeyi yande le nto yamfutshane le nto, aningeni ndawo nina apho. Apho ningenakhona kukufunda qha bese nidlu shut up. Uyafumana into endiyifunayo kukufumana ii-distinctions kuni, ndinibone ningena kwii-courses ezizawunenza nibe ngabantu abangcono ekuhlaleni, okay? Ningayi-yunivesithi egameni nje lokuyaphayana nani nibalo uba benikhe nayofika, nibuye nee-degrees eningeke nizisebenzise ndawo. Funeka izinto ezizawunisebenzela mntakwethu. Indlala inamanyala, nizawuzifumana nisenza izinto eningazimiselanga ukuzenza ngenxa yendlala. And indlala iqala kwizigqibo ozithathayo. Xa ukhetha icandelo omawuye kulo empilweni, qala phaa ingxaki. So xa ukhetha ii-subjects ezifana nee-tourism neentoni, uhluzazi uba wena ukhetha indlala, ngoba uzawuhlomane uyohloloko uxelelwa ngabantu uba mawenze ntoni, futhi baxelele uba ke ngoku into yakho kuyenza iphelile, sebefuna engcono kunawe. Kanti xa uke wafuna izinto ezifunwa ngabantu ababhadlileyo, uzayibona nawe into yoba emveni koba ufumene iimpepha zakho, ufumene inkululeko yokwenza nantoni na oyithandayo, nanini na, naphi na. Yayiva ke ngoku le nto injalo. So what I just said in English, guys, because you see that Xhosa likes to just come out of my mouth, most because this is my language, must say. It's my mother tongue, that one. So what I just tried to say is that, folks, choose degrees that are going to make you prosper, okay? Do not choose degrees for the sake of just having a degree, okay? Naming yourself amongst those who attended some vet universities of this world and some University of Cape Towns of this world. Please make sure that when you come out there, your degree can make a headway for you, and you simply can do anything, anywhere, however much of it you want to do. and to become whatever you wish to become, and make sure that you get to live that reality. Anyway, guys, goodbye. My tablet is already down on the battery, and I'm also tired. Otherwise, let's see each other this evening for those who have my WhatsApp group for our tutorials. We're going to be talking more about similarity and proportionality theorems. Maybe let's start with the proportionality stuff first, then we can add some similarity stuffs as well, perhaps on Wednesday night. Then I will disappear for the reasons I have said already, and we meet again that week. We start tackling past exam question papers, especially for the guys who will be upgrading. We need to start working on those past exam question papers. And now that would mean, guys, big topics and tough questions. Okay, so we'll try to stick to that. Basic stuff I don't have time for, because that you can do by yourself, and it's already easy marks that you always get anyway. So I don't find any passion in running around those lines. And then, of course, guys, we'll see. Close to the exams, we'll try to do full papers on our reviews, on our lessons, because this is when we have to put it together by force, by fire. Yo, so thetha kakhulu ne. Anyway, anyhow, goodbye.